The universe has no center. Imagine standing in the middle of a vast empty desert. No signs, no roads, no compass. Now imagine trying to point to the center of that desert. It's impossible, right? Because the idea of a center only works when there's an edge. In our universe, there is no edge, and so no center. The universe doesn't have a center, not because we haven't found it yet, but because it fundamentally cannot have one. This isn't poetic metaphor. It's the brutal, cold reality of cosmic expansion. When the Big Bang happened 13.8 billion years ago, it wasn't an explosion in space. It was an expansion of space itself. Every point in the universe was once compressed into an infinitely dense singularity. And when it began to expand, it did so not from a single location, but everywhere at once. Think of a loaf of raisin bread rising in the oven. As it bakes, the dough stretches. The raisins, the galaxies, move away from each other. But where's the center of the expansion? From the raisin's point of view, every other raisin is moving away. Each one feels like the center. This is what we experience. From Earth, we see galaxies racing away in all directions, and an alien in a distant galaxy would see the same thing. That's not illusion. That's cosmology. The cosmic microwave background, the radiation left over from the Big Bang, is uniform in all directions. This perfect uniformity is more than eerie. It's evidence. Evidence that the universe doesn't favor a location, not a center, not an edge. Just a continuously stretching fabric where every thread is equally valid. So the question becomes, if there is no center, then where are we? We're not in the middle of anything, not even close. Earth is orbiting a sun, which orbits a galaxy, which drifts among billions of other galaxies in a vast web of dark matter, all floating in expanding space. We're not in a special place. But, and here's the twist, we feel like we are. Our psychology craves centrality. Our religions placed Earth at the center. Then science removed us, placed the sun there, then the galaxy. Now we know even our galaxy is just a dust speck in a supercluster. But this doesn't change how deeply we want to matter. Every time we look deeper into space, we're also looking further back in time. The light from distant galaxies takes billions of years to reach us. We're seeing echoes, not places. The further we gaze, the more stretched reality becomes. And yet, in all this cosmic archaeology, we still don't find a center. Just a history, a dynamic unfolding that continues even now, in silence, in heat, in gravity. The expansion of the universe is accelerating. Galaxies are drifting so far apart that one day, billions of years from now, observers on Earth, if Earth still exists, will see nothing but a dark, empty void. All other galaxies will have vanished beyond the cosmic horizon, forever unreachable, not because they've moved, but because space itself has stretched so much that light from those galaxies will never reach us again. And this future horizon has a strange implication. It means that most of the universe will become unknowable, not because we weren't curious enough, but because the structure of space-time itself will censor it from us. We will be isolated, cosmically lonely, in a sky without signals, without neighbors. So where are we? We're on a floating rock, orbiting a small star in the outer spiral arm of a modest galaxy, in a universe with no center, no edge, and no preferred direction. And that's beautiful, because it means every part of the universe is equally valid. It means that your location, your perspective, your presence, it matters just as much as any other. But this truth also comes with a haunting implication. If there's no center to the universe, then there's no map that leads to the truth. There's no cosmic up or down, no divine coordinate system where meaning is marked in absolute terms. We exist in a decentralized cosmos, where meaning is what we make of it. And yet, the universe is not chaos. There's structure, galaxies, filaments, dark energy flows. It's not random, it's patterned. Just not around you, or me, or anyone. We are not at the center, but we are part of it all. We are fragments of stardust, contemplating the stars. That's not centrality. That's intimacy. So maybe the better question isn't where are we, but when are we? Because in a universe without a center, location becomes less important than timing. You exist now, in the narrow window where stars still shine and galaxies still whisper across space. One day, all of it will be too far away. The the sky will go dark. But you lived in the universe's golden hour, and that's something a center could never give you. So don't look for a middle point on a map of the stars. There isn't one. The universe doesn't curve inward toward a center. It stretches outward into possibility. And somewhere along that stretch, here you are, thinking, wondering, hoping. Time might freeze at light speed. Imagine you're a photon, a particle of light, born in the heart of a star. The instant you're emitted, you leave your origin traveling at the speed of light. For us, it might take 8 minutes to reach Earth from the sun. But from your perspective, time doesn't pass, not a second, not even a heartbeat. This isn't poetic, it's physics. According to Einstein's theory of relativity, as you move faster and faster, time slows down. And at the speed of light, time stops completely. A photon, traveling at 299,792 kilometers per second, is caught in a kind of eternal now. From its point of view, if it even had one, the universe collapses into a flat, frozen moment, where distance and duration lose all meaning. This idea defies our intuition. You and I experience time as a stream. Seconds turn into minutes. We remember the past. We anticipate the future. But light doesn't. It simply is. It exists in an unbroken state of transit. The moment it begins is the moment it ends. Emission and absorption collapsed into one. But how can this be? How can something experience no time? To grasp this, we have to understand that time is not universal. It's relative. Time bends and twists depending on how fast you're moving and how much gravity you're under. This is why astronauts in orbit age just a little slower than we do on Earth. The faster you go, the slower time gets. Until you hit the speed limit of the cosmos. At that speed, light speed, strange things happen. From our frame of reference, a photon can take years, even billions of years, to reach us from distant galaxies. But from the photon's frame of reference, those billions of years shrink to zero. In that instant, it has crossed unimaginable distances without experiencing a single tick of a clock. Think about that. Imagine a photon released from the far edge of the universe at the dawn of time. It travels for 13.8 billion years and finally crashes into the lens of a telescope on Earth. That journey, to us, took longer than civilization itself. But for the photon, there was no wait, no journey, no time. It began and ended in the same breathless moment. This bends the mind. And it should, because time is not absolute. It is not a backdrop. It is part of the fabric of space itself. Something that warps, stretches, and even disappears depending on how you move through it. The photon doesn't freeze time, it exits it. It's the only thing in the universe that travels at this speed. Everything else, matter, people, planets, is bound below that threshold. Time sticks to us like gravity, but light is free. And yet, light isn't conscious. It doesn't know this. But the implications are staggering. If you could somehow ride a beam of light, you would never see the world change. You could reach the Andromeda galaxy in what feels like a single instant. But from the outside, your journey might be measured in millions of years. Of course, you can't ride light. Not really. Anything with mass, like us, can never reach light speed. The faster we go, the heavier we become, and the more energy we need to accelerate. At light speed, that energy becomes infinite. It's a cosmic barrier we can't break. But still, light shows us what lies on the edge of perception. It reveals the limits of our experience. It tells us that time is not a universal river. It's a web of paths, all flowing differently depending on your motion. So the next time you see a ray of sunlight breaking through the clouds, remember, that light may have traveled across millions of years of darkness to reach your eyes, but for the photon, it happened in an instant. A deathless blink. A bridge with no time between its ends. And in that truth hides one of the most humbling and mind-bending lessons of physics. That time, the thing we count, the thing we live by, is not a constant. It's a condition. And light escapes it entirely. Consider this. Light from the cosmic microwave background, the afterglow of the Big Bang, has been traveling toward us for over 13 billion years. It's ancient light, a message from the birth of time itself. Yet, for each of those photons, there was no delay, no anticipation, no endurance. It simply emerged from a primal fireball and arrived here, now. This challenges how we perceive time and existence. Our minds evolved to operate in a slow, material world. But at the quantum level and at relativistic speeds, reality warps. Time can be dilated. Distances contract. And for light, the very scaffolding of reality, space and time, folds into something entirely alien. You might wonder, if photons don't experience time, how do they move? How do they travel? The truth is, from our frame of reference, they do move, blindingly fast. But from their own frame, there is no movement. Just emission and arrival, fused into a single point. It's as if the photon steps outside the timeline we're bound to. This is not just a curiosity. It has implications. When you look into the night sky, you're not seeing stars as they are, but as they were, years, centuries, eons ago. You're witnessing history frozen in light, and yet, that light has no history of its own. It hasn't aged, it hasn't changed, it hasn't waited. What does this say about our universe? That even the fundamental particles that illuminate our world are alien to time itself. And if time is not a universal truth, then our reality is more fluid, more subjective than we ever imagined. This is why physicists speak of space-time, not space and time separately. They are interwoven. And at light speed, that fabric behaves in ways we can't truly comprehend. But we can observe its effects. We can measure the redshift of light stretched across cosmic distances. We can see how light bends around massive objects, because even photons, though massless, are still guided by gravity's hand. In these interactions, light becomes our time traveler, our messenger, our ghost from the past. Every star, every distant quasar, every galaxy smeared across the void is painting its image onto the present moment. Because light allows us to see, not just across space, but through the corridors of time. And here's the most profound thought. In every moment of your life, you are being touched by particles that have crossed the universe without ever knowing time. They strike your skin. They warm your face. They reflect in your eyes. They come from stars that may no longer exist. Yet, their photons are still arriving, still whispering their ancient message. What is it like to be a thing that knows no past, no future, no waiting? We cannot know. But light, in its silence, tells us a secret. That time, as we know it, is not fundamental. It's emergent. It arises only when motion slows, only when mass appears, only in us. And so, light becomes a paradox, a timeless traveler carrying the memory of time, a silent witness to the birth and death of stars, a thread connecting what was with what is. To see it is to see the universe's ancient breath. To feel it is to be touched by the eternal present. That is the power of light, and the stillness it carries across forever. Everything you see is the past. What if I told you that every moment you've ever seen is already gone? That by the time light reaches your eyes, the event that produced it has already passed. You've never truly seen the present. Everything you've ever seen, your own reflection, a sunrise, the face of someone you love, is a memory carried by photons, arriving ever so slightly too late. Let's start with something intimate. Your reflection. And when you look in the mirror, the light bouncing off your face travels less than a meter to the glass and back into your eyes. It's almost instantaneous, but not quite. Light travels fast, about 299,792 kilometers per second, but not infinitely fast. The reflection you see is delayed by mere nanoseconds. It's imperceptible, yet it's there. You are never truly seeing yourself now. You are always chasing your own ghost. Your reflection is a fossil of your face. Now, scale that up. Look at the moon. The light from the moon takes about 1.3 seconds to reach Earth. That glow in the sky? That's the moon as it was over a second ago. A simple glance up is, in fact, a glimpse back in time. The sun? 8 minutes. The sunlight warming your skin is 8 minutes old. When you watch the sunset, you're watching an echo. The sun has already dipped below the horizon. Light is simply catching up. It gets stranger. Look at the stars. Depending on their distance, you might be seeing them as they were years, decades, even thousands of years ago. The light from the Andromeda galaxy, for example, has taken over 2.5 million years to arrive. You're seeing Andromeda not as it is, but as it was before humans ever existed. You are staring into a cosmic memory, a frozen photograph burned into the vacuum of space, and delivered to you across incomprehensible gulfs of time. And yet, your brain tells you it's all happening now. This illusion of simultaneity is hardwired into human perception. Your mind stitches all incoming light into a seamless present, but reality isn't stitched, it's scattered, fragmented, delayed. Even sound, which travels much slower than light, creates further distortion. You see lightning before you hear thunder because sound lags behind light. Your senses are processing fragments of different timelines and fusing them into a single now that doesn't truly exist. Even in conversation, there are delays. A signal takes milliseconds to travel through devices, wires, airwaves. A video call might have you seeing someone a few hundred milliseconds in the past. You nod, you react, you reply, all to a moment that no longer exists. This delay doesn't just live in the sky or in deep space, it's in your fingertips, your screens, your eyes. What about the people around you? If someone stands 10 feet away, you see them as they were about 10 nanoseconds ago. That may sound trivial, but it means there is no such thing as true visual simultaneity. Reality is always catching up with itself. We live in a constant visual lag. Now, imagine looking deeper into space with a telescope. Astronomers aren't just observing far-off stars, they're historians. They're peering into epochs. Galaxies 10 billion light-years away appear as they were 10 billion years ago. Some of the stars we see may already be dead, their light still traveling across space like a farewell letter, arriving after the sender is gone. Even here on Earth, perception is haunted by delay. Our brains take time to process signals. Visual information from your eyes reaches your brain with a delay of around 80 milliseconds. Your brain cleverly compensates, predicting where moving objects should be, creating the illusion of real-time experience. But make no mistake, what you perceive is a reconstruction, not reality. Your mind is a simulator, a time traveler, a painter of echoes. This brings us to a profound truth. You have never seen the present. You are always living in the past, or rather, in a carefully curated hallucination of the past that feels immediate. Your world is a collage of expired photons, a slideshow of what used to be. And in a way, this is beautiful, because it means every sunrise is an artifact, every sunset a preserved goodbye. The universe is constantly giving you memories, not just through emotion or thought, but through light itself. Every moment you witness has already slipped away, but light preserves it for just long enough to reach your eyes. You are always a witness, never a participant in the exact moment you think you're in. Even right now, as you watch this video, light is traveling from your screen to your eyes. The images, the words, the colors, they're arriving slightly delayed. You are hearing my voice just after it left the speaker. We are never truly present together. We are chasing each other's shadows, and when you finally blink, when you look away, remember that even that blink was delayed. Your eyes are always just a little too late. But in that delay, there is poetry, there is mystery, there is time, flowing not like a river you stand within, but like rain falling on your face, each drop a moment already past. So what is the present then? It may not be something you can see, only something you feel, a pulse, a heartbeat, a presence between the photons. And maybe that's what makes us human, not the ability to live in the now, but to imagine it, despite never truly seeing it. And maybe that imagined now is enough. The universe reflects itself. Imagine standing at the edge of the observable universe, holding nothing but a single atom in your palm. One is unfathomably small, the other unimaginably vast. And yet, something about their structure feels eerily similar, almost poetic. Like the universe is hinting at a deeper symmetry hidden beneath all things. At the core of an atom lies the nucleus, densely packed with protons and neutrons, around which electrons whirl in probabilistic orbits, dictated not by rigid lines, but by clouds of uncertainty. Now, contrast that with the architecture of a galaxy, billions of stars spiraling around a dense core, possibly a supermassive black hole, bound not by electric charges, but by gravity's quiet pull. The resemblance between these two entities, separated by more than 30 orders of magnitude, is nothing short of breathtaking. Of course, scientists are quick to point out that these similarities are not rooted in direct causation. Electromagnetic forces govern the dance of electrons, while gravitational forces dictate the motion of stars. But if we strip away the math and observe the forms, the aesthetic symmetry remains. Could the universe be fractal, not just in form, but in function? Fractals are patterns that repeat at every scale, endlessly recursive and infinitely complex. From the branching of trees to the structure of rivers, lightning bolts, and even human veins, nature is obsessed with repetition. So is it too far-fetched to believe that atoms and galaxies might be distant echoes of the same geometric truth? The concept of a fractal universe is more than philosophical musing. It finds grounding in science. Consider the cosmic web, a vast, spider-like structure of filaments stretching across the universe, connecting galaxies with invisible strands of dark matter. When visualized, it looks shockingly similar to neural networks in the brain. In 2020, a study conducted by astrophysicist Franco Vazza and neuroscientist Alberto Faletti compared the structure of the brain to the cosmic web and found striking parallels in complexity and information flow. Two systems, one biological, the other cosmological, connected by a mathematical fingerprint. This raises a profound question. What if consciousness itself is not exclusive to biology, but a structural byproduct of complexity? Could the universe, in all its staggering scale, possess some form of awareness? Not in the anthropomorphic sense, but as a system capable of self-reference? If atoms mirror galaxies and brains mirror the universe, perhaps our thoughts are nothing more than resonant frequencies within a conscious cosmos. The holographic principle adds another layer of wonder. It posits that all the information contained within a three-dimensional space can be described by information encoded on its two-dimensional boundary. In other words, everything we perceive as real might be a projection, a shadow on a cosmic wall. When you see the spiral arms of a galaxy and the orbitals of electrons, perhaps you're seeing different projections of the same underlying code, expressed differently at various scales. Some theorists suggest we live in a universe nested within universes, that an atom could be a galaxy to another kind of being, that every breath you take disrupts patterns in a dimension you'll never perceive. These aren't just fantasies. They're implications drawn from string theory, quantum gravity, and the nature of space-time itself. The deeper we peer into the laws of the universe, the more recursive they become. Even Eastern philosophies echo this idea. The ancient principle of as above, so below appears in Hermeticism, suggesting that all planes of existence reflect one another. In Hindu cosmology, the microcosm and the macrocosm are eternally intertwined. These weren't merely metaphors, they were intuitions that perhaps modern physics is only now beginning to mathematically describe. Consider this. When you gaze into a night sky, you're not just looking outward, you're looking inward too. The photons that left those galaxies millions of years ago are entering your eyes now, stirring thoughts, memories, emotions. In a sense, the universe is observing itself through you. Just as your brain uses electricity to perceive, perhaps the cosmos uses stars, gravity, and light to process its own story. And what about atoms? What if every atom contains a potential for complexity as vast as our own universe, just awaiting the right conditions to unfold? What if your body, made of stardust, is also a constellation to something unimaginably smaller? If all reality is connected through form, through code, through reflection, then perhaps what we call understanding is simply recognition, seeing ourselves in the structure of all things, not because they are like us, but because we are all cut from the same cloth, obeying the same blueprint, repeating an infinite scale. So the next time you look through a telescope or peer into a microscope, consider this. You might be staring into the same infinity, just wearing a different mask. And maybe, just maybe, the universe isn't just reflecting itself. Maybe it's trying to remember what it is. Black holes aren't holes. Imagine the most terrifying trap in the cosmos, one you can't touch, see directly, or escape from. Now picture it not as a hole, but a distortion, a ripple in the fabric of space and time so powerful, it folds the universe inward on itself. That's a black hole. It isn't a bottomless pit. It's not a tear, or a tunnel, or a passage to some other world. A black hole is the corpse of a massive star, so dense, so heavy, that gravity overwhelms every other force in nature and collapses the very structure of reality around it. When a massive star exhausts its nuclear fuel, it dies in a violent explosion called a supernova. What remains is a shrunken, dead core. If that remnant is heavy enough, at least about 3 times the mass of our sun, it collapses not into a neutron star, but into something far stranger. It compresses beyond imagination until it becomes a singularity, an infinitely small, infinitely dense point. Around that point forms the event horizon, the boundary where escape becomes impossible. Not because there's a surface, but because the paths through space curve so intensely inward that no direction leads out. Think of space like a stretched rubber sheet. Place a bowling ball in the middle, and the sheet curves. That's gravity. Now, imagine something so heavy it doesn't just curve the sheet. It punches through and folds it back into itself. That's a black hole. But even that metaphor fails, because black holes don't punch through anything. They don't lead to another side. They warp space in such a way that all paths, all directions, curve toward the singularity. The center isn't a place, it's a trap from which not even light can return. Time, too, distorts near a black hole. To an outside observer, time slows to a crawl at the event horizon. You could watch a clock on the edge of a black hole tick slower and slower until it nearly freezes. For the object falling in, though, nothing feels different. It crosses the threshold without noticing, until the crushing tidal forces stretch and rip atoms apart in a process scientists call spaghettification. Black holes come in various sizes. Stellar black holes, born from supernovae, can weigh up to 20 solar masses, but at the centers of galaxies lurk supermassive black holes, millions or billions of times the sun's mass. Ours, Sagittarius A*, sits 26,000 light-years away and weighs about 4 million solar masses. It doesn't devour everything. It simply warps the stars around it, a cosmic anchor keeping our galaxy in motion. Despite their name, black holes can glow. When matter spirals toward them, it forms an accretion disk. Friction and magnetic forces heat this matter until it blazes with X-rays. It's this fiery swirl we detect, not the black hole itself. The black hole is silent, invisible, yet its influence can be felt across thousands of light years. And here's the strangest part. According to general relativity, the singularity at the heart of a black hole has no volume but infinite density, but quantum mechanics disagrees. It suggests that information can't be destroyed, yet a black hole seems to erase all data about the matter it consumes. This contradiction lies at the heart of one of modern physics' greatest puzzles, the information paradox. Does information escape through subtle quantum radiation? Is the event horizon a hologram storing data? Or is there something deeper, more elusive, we still fail to understand? Stephen Hawking once proposed that black holes aren't entirely black. They emit faint radiation due to quantum effects near the event horizon. This so-called Hawking radiation suggests that black holes may slowly evaporate over trillions of years. But this process is so slow, no black hole has ever been observed evaporating. It remains a mathematical whisper of decay, beyond our reach. Black holes bend more than light. They bend understanding. Every encounter with them stretches our definitions of time, space, cause, and effect. And they serve as a warning that the universe still holds mysteries capable of twisting our most basic ideas into loops of paradox. Black holes are not portals, they are scars. The burned-out remnants of stars, so extreme that the universe itself bends in surrender. We once feared the edge of the map. Now we fear what lurks at the heart of every galaxy. Not monsters, not demons, but the pure consequence of gravity gone mad. A black hole is not the absence of matter. It's matter so compressed, it becomes unrecognizable, a place where the universe forgets its own rules. And yet, from this forgetting may come new insight, new theories, a new way to understand space, time, and the fate of everything. We stare into the void not to escape it, but to learn what makes it possible. And maybe, one day, to tame the collapse, to decode its secrets, to understand the unreachable. Because black holes aren't holes, they're mirrors, dark, silent, and cosmic, that reflect back our deepest questions, about beginnings, about ends, and about what lies in between. Reality needs you to observe it. What if the universe waits for your gaze before it makes up its mind? What if the very act of observation doesn't just reveal reality, but creates it? This isn't science fiction, it's quantum physics. In the strange realm of the quantum, particles like electrons and photons don't behave like tiny billiard balls. They exist in what's called a superposition, a cloud of probabilities. They are not here or there, but both. They don't spin one way or the other. They spin in all ways, simultaneously. Until, that is, someone looks. And then suddenly, the wave of possibilities collapses into one actual event. The particle picks a position, a spin, a path. It becomes real. This is the essence of the famous double-slit experiment. Fire single photons through two slits, and they create an interference pattern, as if each photon went through both slits at once. But place a detector at the slits, and the interference pattern vanishes. The photon chooses one slit. Observation changes the outcome. It's not just bizarre, it's unsettling. This isn't a trick of instruments. It's not about damaging the system by measuring it. It's deeper. The mere knowledge that the particle could be observed alters its behavior. In some interpretations, like the Copenhagen interpretation, observation is what causes the wave function to collapse into definite reality. Before you look, the particle isn't anywhere in particular. It's in a ghostly mathematical state. But the instant you observe it, it decides. So what does that mean for you? It means that on the most fundamental level, the universe is not a fixed stage on which you act. It's an unfinished script that changes based on your attention. Reality isn't entirely objective. It bends subtly to consciousness. And this isn't just philosophy. It's backed by repeatable experiments. Some scientists argue that your role as an observer is what finalizes the universe's choices. But here's where it gets truly strange. You don't even have to be the one looking. In delayed choice quantum eraser experiments, photons seem to make retroactive decisions. The choice to observe or not can be made after the photon has already passed through the slits, and yet, it still changes what happened. It's as if the universe rewrites its own history based on what we eventually choose to see. A cause appears to depend on a future effect. That's a crack in our sense of time itself. The arrow of time bends slightly at the quantum level, and we're left wondering, if future observation can alter past behavior, what else might be entangled in this non-linear web of cause and effect? Some physicists argue this hints at a deeper layer of reality, one where time isn't as linear as we think, and where observation connects not just with space, but with memory, intention, and the act of awareness itself. Others lean toward interpretations like many worlds, where every possible outcome happens and observation just locks you into one branch. But even in those views, the observer plays a critical role. You don't just witness the world, you tune into a version of it. So then, what is observation? Is it consciousness? Is it the act of recording information? Is it simply interaction? No one can fully say. The mystery lingers right at the edge of physics and philosophy. Some believe the observer is fundamental, that the universe requires awareness to manifest. Others say it's a matter of entanglement in information, not sentience. But the question remains, why does your looking change the rules? There's even a term for this mystery: the measurement problem. It's not resolved. It haunts every quantum physicist, every thought experiment, every lecture hall. Schrödinger's cat, both alive and dead until you look, remains the mascot of this unsettling paradox. And now, the most uncomfortable truth. If particles exist in fuzzy superpositions until observed, what about you? Your brain is made of particles. Your neurons fire based on quantum-level events. Could it be that your decisions, your thoughts, yourself, are partly unresolved until something observes you? That sounds like solipsism or metaphysics, but it's not. It's physics leaning against the limits of its own understanding. It's science admitting that we don't know where the line between observer and observed truly lies. Are we watching reality, or is reality watching us? And maybe we never will. But here's what we do know. The act of looking shapes the world. Every glance, every measurement, every moment of attention is a handshake with existence. You're not a passive bystander in this universe. You're a participant, a collaborator, perhaps even a co-creator. Reality at its core is a story still being written, and the pen might just be in your gaze. The page turns every time you choose to look. So, the next time you glance at the stars, remember, they might not shine the same without your eyes. In a universe this strange, maybe your consciousness isn't just a product of reality. Maybe it's a requirement for it. Maybe you're not just made of atoms. You're the reason they take shape. And maybe the cosmos, in all its silence, has been waiting for someone like you, not just to observe it, but to bring it into being. Time moves faster in space, Imagine this. You and your twin are born on the same day. One of you stays on Earth. The other launches into space aboard the International Space Station, orbiting the Earth at 28,000 kilometers per hour. You both live normal lives. Eat, sleep, breathe. But when the spacefaring twin returns to Earth, something strange has happened. He's younger. Not by years, but by measurable milliseconds. Time literally passed more slowly for him. Why? Because motion, gravity, and space itself all warp time. This is time dilation, one of Einstein's most mind-bending ideas. The faster you move, the slower time flows for you relative to someone who's standing still. It's not science fiction, it's science fact. We have measured it using atomic clocks on jets, satellites, and the ISS. The difference is tiny, but real. And over large distances or faster speeds, it grows. And it's not just speed. Gravity also bends time. The stronger the gravity, the slower time flows. That means time on Earth's surface ticks slower than it does at the top of a mountain. And in orbit, above much of Earth's gravity, time ticks faster. That's why GPS satellites need to adjust their clocks to stay accurate. If we didn't, their signals would drift by kilometers every day. So, when we say astronauts age slower, it's true, but only by a hair's width. However, the effect becomes dramatic near massive objects. Imagine a clock near a black hole. To us, watching from a distance, that clock ticks slower and slower. To the person holding it, nothing feels different. But the rest of the universe races ahead. If you could hover just above the event horizon of a black hole without being pulled in, you'd experience just minutes while centuries passed outside. The cosmos would rush forward. Stars would be born and die. Civilizations might rise and fall. But for you, barely any time would pass. That's the power of gravity on time. Now, flip it around. Travel far from any gravity well, into deep space between galaxies, and time would stretch out. You'd age faster compared to someone back on Earth. The universe isn't a flat ticking clock. It's a flexible living fabric where time speeds up or slows down, depending on where you are and how fast you move. This leads to strange possibilities. What if we built spacecraft that could skim near light speed? Time for the passengers would slow drastically. A journey to the nearest star might take 4 years from Earth's point of view, but only days or weeks inside the ship. To those on board, they've made a quick trip. To everyone back home, years have passed. This is the reality we live in. Every second you experience is a little different depending on where you are. The flow of time isn't equal. It's shaped by speed and gravity like clay beneath pressure. Sleep on Earth, and the moon is ticking just a bit faster. Lie in orbit, and Earth seconds drag behind you. No place in the universe shares the exact same clock. And yet, we never notice. These differences are so subtle, they escape our senses. But physics sees them. Clocks prove them. Our very satellites rely on them to work. Without accounting for time dilation, your GPS wouldn't guide you to your destination. It'd get worse every moment. This reveals a hidden truth. Time is not absolute. It's personal, local. You live in your own time stream, influenced by where you are and how you move. And in a universe so vast, with gravity wells, dark matter, expanding space, and accelerating stars, that time stream is never the same twice. Astronauts age slower not because they're special, but because they've moved through a different stretch of reality. Their experience of time was molded by speed and distance. It's not an illusion. It's a shift in the very rhythm of the universe. So, when you look up at the stars, understand that they aren't just distant in space. They're distant in time. Some shine from thousands of years ago. Others may no longer exist, their light still chasing us across the void. And every second you live, somewhere else. Time cheats just a little differently. Now think of time not as a river, but as a landscape. One you walk through differently depending on your path. Gravity bends that landscape like a weight on rubber, creating dips where time slows. Speed stretches it thin, making some places feel shorter than others. And in space, those distortions become visible, measurable, inescapable. In 1971, scientists flew atomic clocks around the world on commercial jets and compared them to clocks on the ground. The result? A measurable difference. Time ticked more slowly on the moving planes. It wasn't just theory anymore. It was proof. A new way of seeing time as elastic, pliable, even breakable. Satellites orbiting Earth must adjust for both kinds of time dilation. special relativity from their speed, and general relativity from being farther from Earth's mass. Without these corrections, your GPS system would be useless within minutes. Each calculation, every map pin drop, is a testament to a universe where time is never constant. On the moon, time moves just a tiny bit faster than on Earth. It's barely noticeable, but it's there. On Mars, slightly slower again. And the deeper you go into a gravity well, like on Jupiter or even inside a neutron star, the slower your time becomes. This means there's no universal now, just local clocks, each living in their own warped version of reality. Let's go further. Imagine a civilization orbiting a supermassive black hole. Due to extreme gravitational time dilation, a single year for them might mean tens of thousands pass in the rest of the galaxy. They could witness the rise and fall of empires in what feels like days. They could study evolution in real time, or escape a doomed future by hiding in a pocket where time crawls. But there's a cost. The closer you get to the edge of time, the event horizon, the more cut off you become. The universe outside races so far ahead, communication becomes impossible. What's 1 minute to you might be an eternity to someone else. In this way, space and time don't just curve, they isolate. And what about us? We're stuck on a planet, spinning at 1,600 kilometers per hour, orbiting a star at 107,000 kilometers per hour. All inside a galaxy, moving through space. We're already riding this relativistic current. We're time travelers, but in tiny, fragmented steps. Still, our perspective limits us. We feel time is steady because we're small. Our senses evolved to ignore these differences. But the universe is not built for intuition. It's built on hidden truths. And one of the greatest truths is this: time is not fair. It moves faster in the void. It stretches near stars. It disappears near black holes. And every second we live, the cosmos cheats just a little more. So, sleep soundly tonight knowing this. While you dream, the clocks aboard satellites tick slightly faster. The astronauts aboard the ISS are aging ever so slightly slower. The moon spins in a faster rhythm than your bed. And the light that enters your window may have left its star before humanity ever learned to speak. This is not just physics. It's poetry in motion. A reminder that we live not in a clockwork universe, but in a dreamscape where time bends, space flows, and reality stretches around our every move. We are passengers on a ship, sailing through a sea of warped time, where each island we pass marks a different rhythm of the universe. And we'll never truly know what it's like to live outside this flow, except by looking at the stars and knowing they tick to a different song. You're mostly empty. What if I told you that you're more nothing than something? That your body, your hand, your heart, everything you think of as solid, is mostly empty space? You're not a solid being. You are a ghost of probabilities, a cloud of flickering energies pretending to be flesh. Let's dive in. At the most basic level, everything you are is made of atoms. Each atom consists of a dense nucleus surrounded by a swarm of electrons. But here's the catch. Those electrons don't orbit like little planets. They exist in clouds, zones of probability. There's no sharp edge, no defined path. And the nucleus? It's tiny. If the entire atom were the size of a football stadium, the nucleus would be a single grain of rice in the center. The rest? Empty, vast, unreachable space. That's not poetic exaggeration. That's scientific fact. Atoms are 99.999999% empty space. Take that seriously. If you removed all the empty space from your body, from every atom that composes you, you'd shrink down to something smaller than a grain of salt. And yet, your mass would stay the same. You'd still weigh the same, just infinitely denser, like a black hole in human shape. So why don't you fall through the floor? Why don't you pass through walls like a ghost? Because of forces, specifically electromagnetic ones. When your hand touches a table, the atoms of your hand never actually touch the atoms of the table. They get incredibly close, but repulsion between the negative charges of electrons prevents contact. What you feel as solid is resistance. It's energy pushing back against energy, the illusion of solidity. Your body is a collection of fields, electromagnetic fields, gravitational fields, quantum fields. Matter is just a disturbance in these fields, a ripple, a dance. The particles that make you up, protons, neutrons, electrons, are not little marbles. They are excitations, waves of energy. The deeper you look, the less thing you find. There is no bottom, no core of solidity, only layers of abstraction. It gets even weirder. The particles that compose you can behave as both particles and waves. This is the principle of wave-particle duality. Depending on how you observe them, they switch behavior. An electron can be a localized point or a spread-out wave of possibility. Observation collapses its nature, meaning that the structure of your reality depends not only on matter, but on the act of observing it. You are not a statue carved in certainty. You are a blur, a maybe, a constantly recalculating equation, a vibration held together by the strange laws of quantum mechanics, and time doesn't help. Even now, the atoms in your body are in constant motion. Electrons flicker in and out of defined locations. Particles emerge and vanish in quantum foam. Your body is more like a field of temporary agreements than a fixed structure, a biological consensus, sustained moment to moment. What about the nucleus, the solid core of the atom? Even that's mostly space. Protons and neutrons are made of quarks, held together by gluons, but the quarks themselves are unimaginably small, and between them, more emptiness, infinite silence. You are made of particles that are made of other particles that are made of mostly nothing. So what are you? You're not the solid object you perceive. You are a pattern, a system of relations, a standing wave in space-time, an arrangement of energy fields operating in harmony. What you call you is the result of trillions of interactions occurring every instant, none of which are truly solid. You are structure without substance, form without mass, a pattern dancing in a void. Even your brain, your source of thought, identity, memory, is composed of atoms that never truly touch. Synapses fire via chemical messengers and electrical charges, but underneath it all, the same vast emptiness. And yet, from that emptiness emerges thought, desire, awareness. This is the paradox. From emptiness comes experience. From nothingness comes meaning. You are a symphony played on invisible instruments, a storm of data stabilized just long enough to call itself a person. When you see your reflection, you're not seeing skin or bone. You're seeing the outer shape of emptiness. Your body is a veil of energy wrapped around absence, and every interaction you've ever had, every handshake, every kiss, every footstep, is just the gentle clash of force fields, never true contact. In truth, we never touch anything. We never hold anything. Everything we do is a negotiation between invisible boundaries. And yet, this illusion of solidity, the convincing mirage that you are whole, complete, touchable, is precisely what allows you to live. You pick up objects, walk on ground, build cities, hold loved ones, all thanks to electromagnetic repulsion masquerading as mass. But it's still an illusion. Your hands are fields, your thoughts are electric. Your body is a ripple in the quantum fabric of everything. Even when you sit still, your atoms never do. They vibrate, spin, interact with invisible forces. You are a storm that never calms, a controlled explosion. The stability you feel is statistical, not absolute. If you could zoom in 1,000,000 times, you'd see chaos. Particles phasing, disappearing, reappearing, noisy, unstable, alive. This makes you more miraculous, not less, because from that chaos emerges coherence. From that silence, a voice. From emptiness, consciousness. You are the universe observing itself, built from nearly nothing, yet capable of love, thought, memory, and choice. You are mostly empty space, but your emptiness hums with potential, and that might be everything. Stars you see might be dead. Look up on a clear night and you'll see stars scattered like glitter on black velvet, each a blazing beacon from unimaginable distances. But what if I told you that some of the stars you're seeing right now no longer exist? Their light, a ghostly echo, is still racing across the cosmos, long after the star itself has died. You're not looking at what is, but at what was. You're watching history unfold in slow motion, painted in light. Light doesn't travel instantly. It moves at 299,792 kilometers per second, an incredible speed by any human standard. But the universe is so vast, so inconceivably immense, that even light must work hard to cross it. The moon's light takes 1.3 seconds to reach us. The sun's, 8 minutes. But stars? Some are hundreds, thousands, even millions of light years away. That means the glow you see now left its source long before humans ever built cities, wrote books, or dreamed of the stars themselves. Take Betelgeuse, for instance, a massive red supergiant in the Orion constellation. It's 642 light years away, meaning we're seeing it as it was in the 14th century. If it has already exploded, if it became a supernova 5 centuries ago, we wouldn't know yet. Its final flash is still traveling toward us. When it arrives, it will paint our sky with brilliance, and by then, the event itself will be ancient history. This isn't just trivia. It's a fundamental truth of how we observe the cosmos. Space and time are intertwined. The farther we look, the further back we peer. There is no single, synchronized now in the universe. Our present is a mosaic of old light, each patch stitched from photons that began their journey across space long ago. It turns our night sky into a museum of time. Each star is a relic, a preserved moment from an unreachable past. Some are still alive. Others, perhaps many, are long gone, their cores collapsed into black holes or scattered across galaxies. Yet, their light remains. It's still on the road, still arriving, still telling a story long after the storyteller is gone. And in a strange twist, this delay is what allows us to understand the universe's birth. The James Webb Space Telescope peers 13.5 billion years into the past, almost to the beginning of time itself. It doesn't show the present-day universe. It reveals baby galaxies, primordial stars, the smoke trails of cosmic creation. We're not just observing space. We're time travelers with glass eyes. Think about that. We can see the Big Bang's aftermath, but not what's happening now, in real time, on the far side of the universe. The cosmos always hides its present. Only the past is visible. And doesn't that make the sky feel a little more haunted? Not with ghosts, but with memories. The light from stars that no longer exist still touches your face. In the cold of night, you're being warmed, just slightly, by the warmth of a sun that died before the first humans drew breath. There's something deeply poetic about that, and deeply human. Because we too echo long after we're gone. Our actions, our stories, our voices, carried through time by those we touch. We're not so different from stars. We live, we burn, we fade. But the light we release, through love, through ideas, through creation, travels on. It may reach someone long after we're gone. Stars that die in supernovae don't end in silence. They forge the very building blocks of life. Carbon, calcium, iron, the ingredients of our bones and blood, were born in cosmic fire. We are the descendants of dead stars. Your hands, your thoughts, your heartbeat. They're the symphony of ancient suns still resonating in a new form. One day, Earth itself may be gone. But its light, reflected from satellites or bounced off our atmosphere, might still be racing across the universe, an echo of a blue planet that once held oceans, cities, and fragile life. And who knows? Some distant observer, far in the future, might see us and wonder, is that place still there? So when you look up at night, you're not just looking at stars. You're witnessing the universe's memory. Every twinkle is a message from the past, a postcard from a star that may no longer exist, but whose light endures. To live under such a sky is to know that nothing truly ends, that even in death, something lingers, that even if we vanish, what we were continues outward, silent, steady, and beautiful. Stars don't disappear. They become stories written in light, and we are the readers, millions of years after the final word was spoken. Consider this. The star HD 140283, nicknamed the Methuselah star, is estimated to be over 14 billion years old. Older, perhaps, than the universe itself, according to some estimates. It lies just 190 light years away. That light has been traveling since before Earth even formed. That means when you look at it, you're peering into a cosmic paradox, a star older than the cosmos as we currently understand it. It challenges our theories, forces us to revise our timelines, and reminds us how little we still know. And in that sense, stargazing is no longer just romantic, it's revolutionary. Each photon that lands on your retina has survived billions of years of travel, navigated expanding space-time, dodged interstellar dust, and found its way to you, so you could see, so you could wonder, so you could ask questions that no one has ever answered. You're not just a passive observer, you're part of this. You are made of this. The atoms in your body once journeyed through space as stellar debris. You are not beneath the stars. You are among them, within them, always. The night sky isn't a ceiling, it's a portal. Every light you see is proof that the past still lives. Every spark is a monument to something once burning, now gone. And the silence? It's not empty. It's full of stories still in transit, still unfolding. So look up. Not just with your eyes, but with your whole being. Feel the ache of time stretching across light years. Feel the grief and the glory of it all. You are here now for this one brief blink in eternity, watching stars that might be long dead, but who still shine. And one day, your light too will travel. The universe might be a hologram. Imagine everything you've ever seen, touched, or experienced. Every building, star, and galaxy isn't as solid or as three-dimensional as it appears. What if all the depth and volume of our universe is an illusion, a projection, a shadow cast from a surface you can't even perceive? This is not science fiction. It's the unsettling possibility proposed by one of the most provocative ideas in modern theoretical physics, the holographic principle. According to this theory, the universe may be a vast hologram, 3D reality projected from a 2D boundary, a reality more unreal than we're ready to accept. This idea didn't begin as wild speculation. It was born from paradox. In the 1970s, physicists Jacob Bekenstein and Stephen Hawking discovered something strange about black holes. The amount of information they can hold isn't tied to their volume. It's proportional to their surface area. That goes against everything we think we know. A library's information is inside its walls, but a black hole's information appears to be smeared across its outer skin. This observation raised a terrifying question. If black holes store reality on their surface, what about the universe itself? Gerard 't Hooft and Leonard Susskind took that idea and pushed it further. They proposed that the entire universe might be governed by the same principle, that everything we see, stars, planets, even ourselves, could be encoded on a distant cosmic surface, like a hologram on a credit card. What we perceive as depth, shape, and volume could emerge from information patterns written on a vast, invisible 2D boundary. If this is true, then reality isn't what we think. It's a projection, crafted from code we can't directly touch. To grasp this, think about a hologram. It's a flat film that, under the right light, creates a 3D image. The image appears to have depth. You can move around it. But it's only light, illusion sculpted by interference patterns. That's the metaphor physicists use. Our universe might be that illusion, a masterfully crafted projection where 3 dimensions and even time arise from deeper, hidden laws. Then, in 1997, physicist Juan Maldacena made it real. He proposed the ADS-CFT correspondence, a mathematical bridge connecting a universe with gravity to a quantum field theory on its boundary. 2 vastly different models, one 3D, one 2D, describing the same reality. Suddenly the idea wasn't just poetic, it was mathematically possible. It meant the universe could indeed be a hologram, and our understanding of space, time, and matter could be fundamentally incomplete. The implications cut to the core of everything. If the universe is a hologram, gravity might not be a fundamental force. It could be an emergent illusion, like warmth from atoms. It could help resolve the information paradox by showing that nothing is truly lost in black holes. Everything that falls in could still exist, just encoded in a place we can't perceive. Even life itself could be part of that code. Some researchers even believe we may have glimpsed traces of this holographic structure. The cosmic microwave background, the faint afterglow of the Big Bang, contains anomalies that might hint at a holographic origin, patterns that don't quite fit with traditional models. Clues, perhaps, left by a deeper layer of physics beneath the one we know. If all of this holds true, then our senses lie. Space isn't what it seems. We may live on a stage without depth, lit by rules we can't fully grasp. And yet, this illusion is consistent, reliable, and beautiful. You wake up, breathe, speak, dream, and every moment you experience could be woven from patterns rippling across a distant, flat surface. But does that make life less meaningful? No. It makes it stranger, more miraculous. You aren't less real. You're more mysterious. You are a projection that can think, a pattern that can feel, a ripple that can ask, why? If the universe is a hologram, then reality isn't built from atoms. It's built from information, from relationships, from logic, from meaning. And that changes everything. It tells us that the cosmos is not a cold machine, but a computation, alive with possibility. That behind the veil of perception is a tapestry of code, perhaps even consciousness. The boundary may be unknowable, but its echoes shape everything. And we are part of that echo. You are not just a body in space. You are a message in motion, a note in the great song of the universe, playing across dimensions. And if the holographic principle is right, that song may have started not in space, but on the edge of it. Because the universe might be a hologram, and you might be its reflection. Gravity isn't a force. What if falling isn't about being pulled down, but about being pushed along the curves of reality itself? What if gravity isn't a force at all, but a distortion in the fabric of existence? That's not a theory. That's Einstein's truth. We grow up thinking of gravity as a force, like magnetism or electricity. We imagine the Earth pulling us downward, the sun pulling on the planets, the moon tugging at the tides. But in Einstein's general theory of relativity, gravity isn't a pulling force. It's geometry. It's the warping of space and time by mass and energy. Objects don't fall because they're yanked. They follow the contours of space-time itself, like marbles rolling along the curves of a stretched rubber sheet. This idea shattered the Newtonian worldviews. For over 2 centuries, gravity was thought to be an invisible force reaching across empty space. But Einstein proposed something radical. Mass tells space-time how to curve, and curved space-time tells mass how to move. You are not being pulled down. You're moving along the shortest path in a curved geometry, called a geodesic. But because we live in this geometry, we feel acceleration. We call it gravity. Take the Earth, for example. The planet curves space-time around it, creating a kind of well. When you jump, you move up briefly, but the warped space-time around Earth nudges you back down. Satellites in orbit aren't being pulled. They're falling around the Earth, forever missing it, surfing the warp of space. The moon isn't held by an invisible tether. It's dancing through bent space-time, spiraling endlessly around the Earth's curved path. This bending of reality isn't just metaphor. It's measurable. We see light bend around stars. This effect, called gravitational lensing, proves that even photons, massless particles, follow the contours of warped space. Starlight curves, time slows. Near a massive body like a black hole, space folds so deeply that even light can't escape. That's not a force. That's a collapse of geometry. Even your body experiences time differently at your head than at your feet. That's gravitational time dilation. Your feet are closer to Earth's center of mass, so time runs ever so slightly slower down there. It's a fraction of a second over your lifetime, but it's real. GPS satellites must correct for this, or your navigation would drift miles off course each day. Gravity bends not just space, but time itself. Now stretch your imagination further. Think of gravitational waves, ripples in space-time produced by massive bodies like merging black holes. Detected first in 2015, these waves aren't carried by a force. They are space itself, stretching and squeezing. They pass through you and Earth, distorting distances by less than the width of a proton. Yet, we've built instruments so precise they can detect them. We're not watching forces, we're watching space breathe. This understanding redefines motion, matter, and perception. Gravity isn't a field reaching out. It's the invisible architecture beneath everything. It determines how galaxies spin, how planets orbit, how time flows, how light travels. And because mass shapes this structure, even the mass in your body warps space around you, infinitesimally so. But the effect is there. You bend reality simply by existing. And this isn't just academic. It challenges what we mean by real. If space and time can be stretched, compressed, twisted, and folded, then they're not passive stages. They are dynamic. Reality isn't a rigid container. It's a responsive medium. It doesn't just hold the universe. It is the universe. And you, by simply having mass, are part of its sculpting hands. But if gravity is geometry, what happens at the extremes? Near black holes, the curves become infinite. Time slows to a stop. At the singularity, physics breaks. Space and time themselves may cease to make sense, and at quantum scales, gravity refuses to cooperate. It doesn't fit with the other fundamental forces. String theory, loop quantum gravity, emergent space, these are all attempts to unify the geometry of the large with the uncertainty of the small. So gravity remains the most familiar yet mysterious aspect of reality. It holds us, shapes us, guides the stars, and yet it may not be a force at all. It may be a symptom of deeper principles, yet undiscovered. Maybe space-time is emergent. Maybe gravity is an illusion caused by entanglement. Maybe the bending of space is just the shadow of something deeper we haven't yet imagined. But for now, understand this. You are not being pulled toward the Earth. You're being guided along a curved path in a woven tapestry of space and time. The floor beneath your feet pushes up to stop your fall, not because gravity drags you down, but because the Earth curves space upward into your trajectory. And that means your every step is a journey through geometry. Every fall, a plunge through bent reality. Every orbit, a dance on an invisible slope. The universe doesn't tug you. It shapes the road you walk, and then lets you glide along its curves. Gravity isn't a force. It's the shape of everything. Cold doesn't exist. Imagine stepping outside into a frozen winter night. You feel the sting on your skin, your breath turns to fog, and your fingers go numb. We say it's cold, but what if that sensation, that bitter chill crawling into your bones, isn't a force at all, but the lack of one? Because cold doesn't actually exist. Not in the way we think. It's not a substance. It's not a thing. It's the absence of heat, just like darkness is the absence of light. Where there is no light, we see darkness. Where there is no heat, we feel cold. But in both cases, it's not presence, it's emptiness. This is a fundamental truth of thermodynamics. Heat is energy, it's motion. Atoms vibrating, molecules colliding. The more heat something has, the more its particles move. When we heat something, we're feeding it energy. When something cools down, it's not gaining cold, it's losing energy. The motion of its atoms slows, and as motion vanishes, the illusion of cold creeps in. It's unsettling to realize that cold is just a measurement of how little life there is in the atoms around us. Ice feels cold because the water molecules inside it have slowed, nearly stopped. Liquid nitrogen feels colder because its molecules barely move at all. But what you're feeling isn't an active presence, it's silence, stillness, nothing. The coldest possible temperature is called absolute zero, 0 Kelvin or 273.15 degrees Celsius. At that point, atomic motion stops, completely. You can't get colder than that. Why? Because there's nothing less than nothing. You can't take away energy that isn't there. No molecule can move slower than motionless. It's a limit set by the universe itself. And we've tried to get there. Scientists have cooled atoms in laboratories to within billionths of a degree of absolute zero. There, strange things happen. Particles lose their individuality. Matter merges into quantum states. Atoms begin to behave like waves. Time and behavior blur into surreal patterns. You're no longer in the realm of frozen landscapes. You're in a theater of pure physics. But absolute zero is unreachable, not just difficult, impossible. It would require removing every trace of energy from a system, and that would take infinite time and effort. You can always get closer, but never arrive. Cold is the ghost that haunts heat's departure, but it never stands on its own. And here's the strangest part. You can never feel cold directly. What you feel is heat leaving you. When you touch metal in winter, it feels freezing. Not because the metal is pouring cold into you, but because it's pulling your heat away faster than wood or cloth would. The faster that heat is stolen from your body, the colder you feel. Cold doesn't strike, it empties. It's a theft of energy, not a gift of something new. It's the space left behind when warmth retreats. That's why space, outer space, isn't cold in the traditional sense. There's nothing out there to pull your heat away quickly. It's vacuum. And in a vacuum, heat has nowhere to go. You don't freeze instantly. You radiate slowly, alone, into a vast nothing. This is the terrifying elegance of thermal reality. There is no cold ray, no cold energy, only the draining away of warmth. The universe doesn't blast us with icy winds. It forgets to warm us. The cold doesn't kill. The heat leaves. And when the last atom ceases to move, what's left is not cold. It's nothingness. Even language betrays us. We say it's cold, as if it's a thing outside ourselves, but really, it's something missing within us. A measurement of energy lost, not energy gained. The universe doesn't deliver cold, it allows heat to vanish. And in that silence, we shiver. So next time you step into the frost, know this. The cold isn't coming for you. The warmth is fleeing. You aren't being attacked, you're being abandoned. And that absence, that retreat of energy, is what makes you tremble. We fight cold not by creating heat, but by conserving it, trapping motion, holding energy close. Fires burn not to make cold go away, but to fill the emptiness it leaves behind. Every jacket, every blanket, every heater is a shield against loss, not a weapon against a foe. Because cold was never your enemy. It was never anything at all. It was just the void. And it will freeze you because nothing can. Think of it like a symphony where the music slowly fades until there's only silence. The silence doesn't arrive. It's simply what's left when sound goes missing. That's what cold is. A missing melody. A quietness in the dance of molecules. In Antarctica, temperatures can plunge below 89 degrees Celsius. But even there, the air isn't filled with cold. Instead, it's simply lacking in the warmth that life clings to. In deep space, where particles are few and far between, the temperature doesn't measure how cold it feels, but how little thermal motion exists. It's a haunting emptiness, not of matter, but of energy. Cold doesn't glow. It doesn't move. It doesn't spread. It waits. Waiting for heat to be lost, radiated, conducted away. Your body is always bleeding warmth into the world, into your chair, the air, the night sky. Without a source to replenish that energy, your internal furnace slows, and when it gets too low, you shut down. This is how frostbite works, not by the invasion of cold, but by the slow starvation of warmth. Your body redirects heat to the core, abandoning your fingers and toes. Cells begin to die, not because cold invaded, but because energy left and never returned. And yet, this ghost of cold governs life. Every living cell fights against it. Every heartbeat is a rejection of entropy, a scream into the silence that says, I am still warm. The second law of thermodynamics tells us that energy will always spread out, always dissipate. Left alone, everything cools. So we burn, not because we love the flame, but because we fear its absence. Civilization itself is built on heat, fires, engines, stars. And in the end, the universe itself may face the same fate. A slow cooling, a heat death, a final frozen silence where even motion ceases. Not because something attacked, but because everything stopped moving. This is what cold truly is, the ultimate surrender, the final quiet. And now you understand. Cold isn't real, but its nothingness can kill. Most of the universe is invisible. Imagine walking into a room, turning on the lights, and seeing only 5% of what's actually there. Everything else remains hidden. Invisible to your eyes, your tools, your understanding. That's the universe we live in. The stars, the planets, the gas clouds, galaxies, they're dazzling. But they're only a sliver of the cosmic truth. Because 95% of the universe is something we can't see, something we can't touch, something we can't fully explain. Let's start with the 5% we do know. Ordinary matter. That includes everything you've ever seen or touched. Your body, your phone, the oceans, stars, dust, all made of atoms. But when scientists looked closely at how galaxies spin and how the universe expands, the math didn't add up. The visible matter simply wasn't enough to account for the behavior of everything we observed. Something else had to be there. Enter dark matter. It doesn't emit light. It doesn't absorb it either. It's completely invisible, but its gravity leaves fingerprints. It pulls on galaxies, bends light through gravitational lensing, holds massive clusters together like glue. Without it, galaxies would fly apart, stars would drift away, the universe would unravel. Dark matter makes up about 27% of the universe, and we still don't know what it is. We've built detectors in underground labs, launched satellites into space, smashed particles together at near-light speed, still nothing definitive. But the rabbit hole goes deeper. Because dark matter isn't even the majority of the invisible universe. That title belongs to something even stranger, dark energy. In the late 1990s, astronomers studying supernovae discovered something shocking. The universe wasn't just expanding, it was accelerating. Space itself was stretching faster and faster. This defied everything we expected. Some unseen force, was pushing the universe apart. That force is what we now call dark energy. Dark energy makes up about 68% of the universe. It's not just invisible, it's enigmatic. Unlike matter, it doesn't clump, it doesn't attract, it pushes. It acts like negative gravity. We don't know if it's a property of space itself, a new field, or something even more exotic. All we know is this: without it, the cosmos wouldn't be accelerating, galaxies wouldn't be flying away from each other. The fate of the universe might be entirely different. So, let's put it together. Ordinary matter, the kind we understand, makes up just 5% of everything. The rest is unknown. A ghost universe surrounding us, shaping us, defining our destiny. This means every time you look up at the night sky, you're seeing only the tip of the cosmic iceberg. The beauty you witness, the stars, the nebulae, the galaxies, is only a fraction of what exists. The real bulk of reality is hidden in shadow. It challenges everything we believe about knowledge. We pride ourselves on our instruments, our theories, our discoveries, but here, in the most fundamental truth of the cosmos, we are blind. We're children stumbling in the dark, trying to map a room with our hands pressed to the walls. And yet, this isn't a failure. It's an invitation to ask better questions, to imagine stranger realities, to accept that what we know might be the smallest slice of what's possible. Dark matter, dark energy. They're not science fiction. They're science fact, verified by data, whispered through gravitational pull, etched in the redshift of galaxies. They are the scaffolding of our universe, and we don't yet understand them. We live inside a cosmic illusion, a theater of light, color, and gravity built on an unseen stage. Dark matter is the scaffolding. Dark energy is the engine. And we are actors who don't know the shape of the stage or the direction of the script. The universe is expanding, yes, but it's not just stretching. It's accelerating into mystery, into more emptiness, into deeper unknowing. The further we look, the less we understand. And yet, we feel grounded. We feel like we know our place. But how can we be grounded when we are floating in 5% of the truth? What if the rules of existence we base our lives on are written by forces we cannot detect? Dark matter could be woven from exotic particles that never interact with normal matter except through gravity. They may pass through you every second without leaving a trace. And dark energy? It could be the breath of another dimension, the curvature of reality itself, or a hint that space is not what we think it is. This is the real cosmic horror. Not monsters or black holes, but that the grand majority of the cosmos exists outside our reach. We don't just live in the unknown, we are shaped by it, carried by it, trapped inside a puzzle where 95% of the pieces are invisible. How do you solve a puzzle when most of it refuses to be seen? And yet, we try, with telescopes tuned to ghostly signals, with underground detectors hoping for a flicker, with equations scratched into chalkboards that dare to glimpse the invisible. Because maybe understanding isn't the only goal. Maybe wonder is enough. Maybe the vastness of the unknown isn't something to fear, but something to admire. A reminder that our greatest limitation is also our greatest gift. The ability to imagine what we cannot see, to question what we cannot hold, to believe that reality is always deeper than our perception. Dark matter, dark energy. They are the shadow twin of everything we know. And they are not waiting to be found. They are already here, already holding you, pushing you, defining the shape of your life. You just can't see it. Not yet. Vacuum has weight. Imagine staring into the void, into empty space, the great black between stars. We call it nothing, but what if that nothing isn't empty at all? What if the vacuum of space has weight, energy, and even influence? What if that invisible silence is the loudest force in the entire universe? For centuries, scientists believed that a vacuum, true emptiness, was exactly that. A place without matter, without particles, without energy. But modern physics tells a stranger story. The vacuum isn't empty. In fact, it's brimming with restless activity. It's a sea of fluctuating energy, a foam of probabilities where particles blink in and out of existence, like cosmic fireflies. This isn't speculation. It's rooted in quantum field theory, the the most precise model of reality we've ever created. According to it, every point in space is filled with fields, and even in the absence of particles, those fields still vibrate. They can never be entirely still. That base-level hum is known as zero-point energy, and it's not zero at all. In 1948, physicist Hendrik Casimir predicted a bizarre effect. If you place two uncharged metal plates extremely close together in a vacuum, they will be pushed toward each other, not by magnetism, not by gravity, but by the vacuum itself. Why? Because the space between the plates excludes certain wavelengths of quantum fluctuations, creating a pressure imbalance, and this force, now called the Casimir effect, was observed. Emptiness has power. This discovery raised unsettling questions. If a vacuum has energy, then that energy must have mass. Einstein's equation E as mc2 tells us that energy and mass are interchangeable. So, in a sense, the vacuum does have weight. It warps space-time. It stretches the fabric of reality. But the implications go even deeper, because this invisible energy may be driving the universe apart. In the late 1990s, astronomers studying distant supernovae discovered that galaxies aren't just moving away from each other, they're accelerating. Something is pushing them faster and faster into the abyss. The culprit? A mysterious force known as dark energy, which accounts for nearly 70% of the entire universe, and its nature is still largely unknown. One leading theory is that dark energy is vacuum energy. The very emptiness between galaxies is expanding space itself, like an inflating balloon. And the more space expands, the more vacuum there is, which means more energy, which means faster expansion. It's a feedback loop written into the bones of the cosmos. So when you look into the night sky, the dark isn't passive, it's active, it's dynamic. It's doing something. It's like a silent wind that we can't feel, but that drags entire galaxies with it. Now imagine the implications. The universe is not a stage on which matter plays. It's a character in the play. Empty space has agency. It can curve around mass, respond to energy, even accelerate the expansion of reality itself. This means that the future of the cosmos might not be shaped by stars or black holes, but by the weight of nothing. Let that sink in. And here's the twist. According to calculations in quantum theory, the vacuum should have an absurdly high energy, 120 orders of magnitude higher than what we observe as dark energy. That's a 1 followed by 120 zeros, the biggest mismatch between theory and observation in the history of science. We don't know why the observed vacuum energy is so small. Some call it the worst theoretical prediction ever made. Others think it's the greatest clue we've ever been handed. What if the vacuum is tuned, balanced on a razor's edge that allows galaxies to form, stars to shine, life to emerge? A slightly stronger vacuum energy, and the universe would have torn itself apart before atoms formed. Slightly weaker, and gravity would have crushed everything into a chaotic soup. We live in a Goldilocks vacuum, just right, and no one knows why. Some physicists propose the idea of a multiverse, that our universe is one bubble among countless others, each with different vacuum energies. We just happen to live in one that permits our existence. In that view, the weight of the vacuum becomes not just a physical fact, but a cosmic selection mechanism. The void chose us. And yet, there's still more mystery. Could the vacuum change? Could its energy decay? Some theorists fear that we live in a false vacuum, a temporary state of balance. If it collapsed into a lower energy state, it could trigger a phase transition that would rewrite the laws of physics. At the speed of light, everything we know could vanish, not in fire, but in silence. But until then, we live within it. We float in an ocean of dark energy. We build our homes, our lives, our futures in a space that's expanding, flexing, whispering, beneath our notice, but never truly still. Vacuum has weight, and in its quiet gravity lies the fate of everything. So the next time you pause under a starry sky, try to imagine not just the twinkling points of light, but the vast dark ocean in between. That space, the so-called nothing, is alive with invisible waves, hidden storms of energy, and quiet forces that outpower even the brightest galaxies. What you see as absence is actually the engine of the cosmos. The vacuum is not the background, it's the architect. The weight of nothing is what holds everything together and may one day pull it all apart. Your position changes everything. What if reality isn't something fixed, but something that shifts depending on where and how you look at it? In quantum physics, this isn't poetic metaphor, it's law. Your position changes everything. Not spiritually, not philosophically, physically. The act of observing a quantum system alters it. When you look, the universe answers, and the answer depends on how you ask the question. In classical physics, the world is objective. A tree falls in a forest, whether you're there or not. But in quantum mechanics, reality behaves like a riddle that solves itself only when someone is paying attention. And the solution you get depends entirely on where you're standing, how you measure, and what you're willing to see. The most haunting example? The double-slit experiment. Fire electrons one by one at a barrier with 2 slits, and a detection screen behind it will show an interference pattern, like a wave. That means each electron interferes with itself, behaving not as a single particle, but as a spread-out probability. But the moment you set up a device to observe which slit it passes through, the interference disappears. The wave function collapses, and the electron behaves like a particle. It chooses a slit. This isn't about equipment malfunction or observer bias. It's built into the universe. The observer is part of the equation. Until the system is measured, it remains in a state of superposition, a combination of all possible realities. Observation selects one. Now, consider spin, a fundamental property of quantum particles. A particle can be spin up or spin down, but which it is depends on how you measure it. If you change your angle, the outcome shifts. There's no universal spin, no objective answer, only observer relative results. This isn't a defect in our tools, it's a feature of existence. Einstein hated this. He famously said, "God does not play dice." But quantum mechanics responds, maybe the dice are loaded by the way you look. The moon still exists when you're not looking, yes. But at the quantum level, your gaze matters. Your perspective writes reality. Entanglement twists this further. 2 particles can become linked so that the state of one instantly determines the state of the other, no matter how far apart they are. Measure one here, and the other over there reacts, instantaneously. Einstein called it spooky action at a distance. But it's been proven. The cosmos allows non-local connections. Change your position in one place, and you affect the outcome in another. And this isn't confined to particles. It echoes into consciousness, choice, and change. Your beliefs, your expectations, your emotional stance, all these influence how you interpret the world. The question isn't just, what is real? It's, from where are you looking? Even memory obeys this principle. Every time you remember something, you alter it. You reconstruct the past based on your current emotional position. Reality doesn't live in stone. It lives in relationship, in interaction, in shifting frames. The observer effect invites a deeper truth. You are not a bystander. You are a participant, an entangled node in the network of causality. You are not watching a movie. You are helping write the script in real time just by being present. This realization isn't just scientific, it's empowering. If your observation changes reality, then you have influence. You are not insignificant. You are not separate. You matter, not just emotionally or morally, but fundamentally. You shape the unfolding of the universe. So, what happens when you shift your position? What becomes possible when you ask a different question? The future bends. Probabilities collapse into new choices, new timelines, new truths, and none of it happens without you. Because at the quantum level, the universe is not made of things. It's made of events, of possibilities, of relational truths. And every event includes you. So remember this. When you look out at the world, you're not just observing, you're engaging, you're collapsing wave functions. You're deciding which version of reality becomes real. Your position isn't just a place, it's a force, and the universe is waiting for your angle. Planets can float on water. Imagine tossing a planet into a bathtub and watching it float like a rubber duck. Sounds absurd, right? But if you had a big enough pool, one wide enough to fit a planet like Saturn, you could watch it bob gently on the surface. Because despite its massive size, Saturn is so light it would float on water. This fact sounds like a joke, a science classroom meme, but it's real. Saturn, the second largest planet in our solar system, is mostly made of gas. It has an incredibly low density, just 0.687 grams per cubic centimeter. Water's density is 1 gram per cubic centimeter. That means Saturn, pound for pound, is less dense than water. If densities were the only rule, Saturn would float. But what does that really mean? It means Saturn, for all its grandeur, its rings, its storms, its moons, has the consistency of a giant, puffy ball. Its outer layers are hydrogen and helium. Beneath that, there may be layers of metallic hydrogen and a small rocky core, but most of the planet is a light, compressible cloud. That's why it's so low in density. It's not that Saturn is small, it's that its mass is spread thin over an enormous volume. It's more balloon than bowling ball. So imagine the scale of this hypothetical cosmic swimming pool. To submerge Saturn, you would need a body of water over 120,000 kilometers wide and deep. That's almost 10 times Earth's diameter. Oceans wouldn't cut it. You'd need something closer to a planetary water sphere, a water planet. Or perhaps a science fiction dreamscape where stars float like lanterns and gas giants drift on oceans of light. But beyond the visual metaphor lies a deeper point. Mass and size don't always mean heavy. Our intuition tricks us. We imagine Saturn as dense because it's big. But gravity doesn't just care about size, it cares about mass over volume. And that's why this fun fact isn't just trivia. It's physics teaching humility. Earth, for example, has a density of 5.5 grams per cubic centimeter, much heavier than water, much heavier than Saturn. Jupiter, though larger than Saturn, is also denser, 1.3 grams per cubic centimeter, so it would sink. But Saturn? It's the featherweight of the solar system. It only looks intimidating. And if Saturn could float, what about the other gas giants? Uranus and Neptune are close. Their densities are just above water. They wouldn't quite float, but they'd come close to neutral buoyancy. It's a strange reminder that appearance isn't everything in space. Composition matters. So do layers, pressures, and structure. Now ask this. Why is Saturn so light? It's because it never got enough mass to compress itself further. As planets grow, gravity crushes them, shrinking them even as they get heavier. Jupiter gathered more mass, so it squeezed its hydrogen tighter. Saturn never reached that critical mass, so it stayed puffier, more diffuse, like a half-inflated balloon next to a tightly packed one, and this puffiness gives Saturn more than just buoyancy. It shapes its weather. Its winds can reach over 1,800 kilometers per hour, far faster than anything on Earth. It shapes its rings, too. Icy debris in perfect balance, held not by contact, but by gravity and speed. It makes Saturn a world of grace, elegance, and surprise. Of course, Saturn floating on water is just a theoretical curiosity. There is no ocean big enough. There is no need to test it. But the idea carries weight, ironically enough. It reminds us that density is not visible, that reality bends around numbers and laws, not perception. That sometimes the biggest thing in the room is also the lightest, and it invites deeper questions. What does it mean to float? What does it mean to sink? In the void of space, there's no up or down, no water to test buoyancy. But still, this fact cuts through. A planet, majestic and ringed, made mostly of hydrogen. So light that in another universe, it might drift on an alien sea. So, when you think of Saturn, don't just think of storms and rings. Think of delicacy. Think of fragility hidden in immensity. Think of a planet that could float like a lily pad, not because it's weak, but because the universe made it that way. And the implications don't stop there. This idea of a massive world that floats forces us to rethink strength and substance. We equate mass with power, gravity with dominance. But Saturn defies that instinct. It's a giant whose weight is deceiving, whose might is masked in softness. It is not less powerful for being less dense. Its storms are larger than Earth. Its magnetic field is immense, and its rings, those delicate bands of frozen beauty, extend farther than you might imagine, shaped by particles no thicker than snowflakes. Saturn exists in tension. It is both storm and silence, massive yet light, fierce yet floating. It challenges our senses. On Earth, we live in a world where heaviness equals importance. But in space, it's often the opposite. The largest stars burn out the fastest. The brightest flashes fade the quickest, and the biggest planets can float. So imagine again that ocean large enough to cradle Saturn. Imagine lowering it gently into the water, its rings glinting like glass, its clouds churning with unseen winds. It wouldn't splash, it would settle, float, drift. It would rest lightly on the surface, not from weakness, but from harmony. This cosmic flotation is more than a fun fact. It's a metaphor, a lesson. That size alone is not destiny. That mass does not always sink you. That in a universe where black holes weigh billions of suns and galaxies collide in slow motion, even a planet can teach you about grace. Saturn floats not because it's small, but because it's balanced. And sometimes, balance is the most powerful thing in the cosmos. The universe had a birth, but no cause. What caused the universe to begin? It's the question behind all questions, the one that haunts philosophers, priests, and physicists alike. The universe began 13.8 billion years ago in an event we call the Big Bang. Not an explosion in space, but an explosion of space itself. Everything, matter, time, energy, even the dimensions we live in, erupted from a single point, a singularity, a place where the laws of physics no longer make sense. But what caused that? We don't know. Maybe we'll never know. Because here's the unsettling truth. The universe had a birth, but no known cause. And maybe no cause at all. Our minds are wired to crave causality. Every effect must have a cause. If a glass breaks, it was dropped. If a star explodes, it burned out. But what if the biggest event in the cosmos, the beginning of everything, happened without a reason? The laws of physics as we know them break down at the singularity. Time doesn't work the same. Space folds into itself. Gravity and quantum mechanics, our two most powerful theories, stop agreeing. In that moment, before doesn't exist, because time itself didn't exist. There was no when before the Big Bang, no past, no ticking clock, just nothing. So, what came before the Big Bang? That question might not even make sense. It's like asking, what's north of the North Pole? The Big Bang didn't happen in time, it created time. Asking what happened before is asking for a cause in a realm where cause and effect don't apply. And yet, we try. We build theories. Some say the universe came from a quantum fluctuation, an unstable nothing that bubbled into being. Others propose a multiverse, where countless universes pop in and out of existence, like sparks from a fire. In those models, our Big Bang was just one breath in an eternal cosmos. But even then, why? Why should anything exist at all? That's the deepest mystery. Nothing, true nothing, is unstable. At the quantum level, particles can appear from empty space, as long as they vanish quickly. It's called quantum tunneling. Virtual particles flickering in and out of existence. Could the whole universe be one of those particles? A fluctuation in the void that got stuck? That expanded instead of vanishing? It sounds impossible. But in physics, impossible just means not yet understood. And here's the twist. Maybe the universe doesn't need a cause. Maybe our demand for reason, our hunger for explanation, is a human trait, not a cosmic law. Cause and effect are part of the universe. If the universe itself didn't exist, then maybe cause doesn't either. This is what makes the Big Bang so terrifying and so beautiful. It's not just the beginning of everything we see. It's the end of everything we can explain, a boundary, a horizon past which our tools, our logic, and even our imagination start to dissolve. We want answers, but the origin of the universe might not offer one, not because we're stupid, but because the question might be meaningless. Not every why has a reason, not every beginning has a spark. And so, we stand here, billions of years later, on a tiny planet, wondering how we got here, why we're here, what lit the first flame. And the only sound we hear in reply is the echo of the Big Bang itself, stretched into the faint whisper of background radiation. A sound with no voice, a birth with no mother, a beginning with no trigger. Perhaps the universe is its own reason. Perhaps it simply is. And maybe that should be enough. Think about what that really means. The most significant moment in all of reality, the birth of existence itself, might not have had a spark, a starter, or a plan. It just occurred. No hand pushed a button. No whisper said, "Let there be light." Light was simply there. In our everyday lives, that notion feels impossible. A tree grows because a seed was planted. A storm forms because of pressure and temperature. But when we trace our universe back to the singularity, the links between cause and effect start to collapse. All roads lead to a cliff edge, beyond which there is no road at all. Scientists and mathematicians have constructed countless models to peer past the Big Bang. Some envision a cyclical universe, a cosmos that expands, contracts, and then is reborn in a rhythmic dance. Others imagine an eternal inflation, with baby universes budding off like soap bubbles in a cosmic foam. But each of these, while intriguing, still avoids the central wound. Why is there something rather than nothing? To that, we have no answer. Maybe the laws of nature allowed for a spontaneous beginning. Maybe the vacuum wasn't truly empty. And from its fluctuations, the laws of quantum mechanics gave birth to particles, energy, and eventually stars and minds capable of asking these very questions. Or maybe the entire notion of beginning is just a limitation of our own understanding. Perhaps time, space, and existence aren't linear arrows, but endless spirals, or loops, or echoes. Perhaps the universe had no first moment, just a threshold beyond which our language crumbles. The deeper we dig, the more we discover that nature isn't obligated to make sense to us. It doesn't owe us a reason. It simply exists. And so, we build telescopes that scan the microwave background, the oldest light in the universe, trying to hear whispers from that first breath. We write equations. We debate philosophy. We stare into the night sky, yearning for a glimpse of before. And what we find is silence. A sacred kind of silence. Not absence, but mystery. A silence that holds everything. Every galaxy, every atom, every heartbeat. All born from a moment we can't explain. A moment we might never reach. A moment that might never have had a why. But here we are. Conscious, aware, thinking about thinking, wondering why anything exists at all. And maybe the miracle isn't the Big Bang. Maybe the miracle is us, asking about it. You share DNA with the stars. What if I told you that every breath you take, every heartbeat, every cell in your body is made of ancient starlight? That you are not merely on Earth but of the universe itself? That the iron in your blood, the calcium in your bones, the oxygen in your lungs was all forged in the furnace of a dying star? This is not poetry. This is science. You are recycled stardust with thoughts and memories. A constellation collapsed into human form. Let's go back billions of years, before Earth, before the Sun, before even the galaxy as we know it. In the young universe, there was only hydrogen and helium, the simplest elements. The cosmos was dark, quiet, blank. But then, stars were born. Massive ones, burning violently. Inside their cores, fusion began. Hydrogen collided and merged to form helium. And then came carbon, oxygen, nitrogen. The heavier the element, the more energy it required. But the real magic happened when those stars died. In the final moments of a massive star's life, it collapses in on itself and explodes in a supernova. That explosion is one of the most violent events in the universe, hotter than anything you can imagine. It's here that the heaviest elements are born: iron, gold, uranium, all created in a flash of destruction. These elements are then scattered across space, seeding galaxies with raw ingredients. Over time, gravity pulls these particles together. They form new stars, new planets, and eventually, new life. You are part of that cycle. You were forged in it. Every atom in your body has a history longer than the Earth itself. The carbon that forms your DNA, the calcium that builds your teeth, these were once part of stellar cores. You are not just in the universe. The universe is in you. The Earth is not some isolated stage for life. It is a gathering of ancient pieces, cosmic relics, drifting dust, unified by gravity and time. Life arose here, but its ingredients came from the stars. You are literally the universe becoming aware of itself. A brief, fragile flicker of starlight, thinking, wondering, dreaming. When you look up at the night sky, you are not looking at something foreign. You are looking at your family tree. The stars are your ancestors, the galaxies, your origin story. You don't just share DNA with the stars, you share history, identity, destiny. You are the echo of cosmic explosions, the residue of eternity. Even now, your body is part of the same cycle. You inhale oxygen that was forged billions of years ago. You drink water that contains hydrogen from the Big Bang. Your skin, your bones, your eyes, every part of you is ancient. Even your emotions, love, fear, joy, are reactions in a body sculpted by cosmic chemistry, stardust with feelings, explosions that learned how to cry. Think about this. The atoms in your left hand may have come from a different star than those in your right. You are a mosaic of stellar remnants, assembled not by design, but by gravity, time, and cosmic chance. Each element has its own origin, its own violent birth. You are walking star debris, fused into form by the slow work of evolution and chemistry. When you touch someone, when you fall in love, when you cry, it's not just emotion, it's chemistry, it's physics. It's the universe expressing itself through you. Feelings are not separate from the cosmos. They are the cosmos, rendered conscious. You are not merely alive, you are how the universe feels when it becomes aware of its own existence. And what a beautiful irony. The most chaotic, destructive events, the death of stars, are responsible for the birth of life. Supernovae tear stars apart, but in doing so, they create the building blocks of everything we know. Your body is made of violence turned into balance, entropy turned into breath. Even the gold in your jewelry, the platinum in your electronics, the iodine in your medicine, these didn't originate on Earth. They were born in collisions between neutron stars, cataclysmic events that warp time and space. These ingredients traveled billions of years to become part of your life. You wear the aftermath of ancient cataclysms around your neck. This should change the way you see everything. You are not mundane. You are not made of cheap matter. You are forged from the rarest things in the cosmos. And when you suffer, when you doubt, when you wonder if you matter, remember this. The universe spent billions of years preparing your ingredients. You are the result of cosmic patience. Even your mind, the spark behind your thoughts, is shaped by ancient atomic patterns. Neurons fire, memories form, emotions pulse, all through matter older than the Earth. You are the universe, thinking about itself, confused by itself, amazed by itself. So, next time you look at the stars, don't just wish upon them. Say thank you. Because they are more than distant lights. They are your ancestors. Your body is their gift, your existence, their echo. And when your time comes to an end, you will return to that same process. Your body will fall back to Earth, and the atoms will disperse. They'll drift into the soil, into the air, into water. And maybe, just maybe, some part of you will help grow a tree, or rise into the clouds, or light up in a newborn star. From stars you came, to stars you shall return, and all the while you carry their memory in your very bones. The universe can see itself through you. Imagine being the eyes of the universe, the ears, the mind. The moment you opened your eyes this morning, you didn't just wake up. You helped the universe become aware of itself again. That's not metaphor. It's one of the most profound truths we've ever uncovered. Your consciousness is not separate from the cosmos. It is the cosmos, looking back on itself and asking, what am I? You are made of atoms that were forged in stars. Every particle in your body once existed in the heart of a supernova. Your hands are stardust. Your breath is recycled ancient air. You are not in the universe. You are of it. And somehow, against impossible odds, those atoms arranged themselves in such a way that they began to think, to dream, to reflect. Out of silent, unconscious matter arose a voice that could say, I am. This is the great cosmic paradox. The universe is both observer and observed. It birthed galaxies and stars, planets and oceans. And then somehow, neurons and thoughts. 100 billion galaxies gave rise to a single brain that could wonder where those galaxies came from. It's as if the cosmos grew eyes to see its own grandeur, and the scale is staggering. Trillions of cells inside your body coordinate every thought, memory, and movement. Each cell is a universe of complexity on its own. Your brain contains more connections than there are stars in the Milky Way. Yet all of it, everything that makes you you, emerged from the same chaotic explosion 13.8 billion years ago that gave rise to everything else. Physics doesn't separate you from the stars. It links you to them. Consciousness, then, is not an exception to the universe. It is an extension of it. Some scientists call it the hard problem. How subjective experience arises from objective matter. But what if it's not a problem at all? What if it's inevitable? The culmination of complexity that had no choice but to ask, what is all this for? From ancient mystics to modern physicists, this idea has echoed across time, that we are not merely observers of the universe, we are participants in its becoming. Every time you learn, or wonder, or love, the universe changes slightly. Information is encoded, entropy shifts, probability collapses into choice, and choice becomes reality. When you look at a mountain, the mountain is not just being seen, it is seeing through you. When you study a star, you are not apart from it. You are it, analyzing itself through the lens of thought. Your questions about the universe are the universe's questions about itself. Think of every philosopher, poet, scientist, each reaching for truth, each wondering why. They were all neural branches of the same cosmic tree, separate in appearance, connected in essence. When Newton described gravity or Einstein spoke of space-time, they weren't inventing those ideas. They were uncovering them, pulling veils off parts of the universe that were always there, waiting to be remembered. And in that act of remembering, the universe grew more complete, more awake. You are not a mistake. You are not an accident. You are the product of 13.8 billion years of evolution, combustion, emergence, and reflection. And what makes you conscious? What gives rise to this inner theater of thought? It's still one of the most mysterious and sacred processes in existence. We don't fully understand it, but we live through it. That makes you both puzzle and answer, question and echo. Even your fears, your joys, your sadness, these are not anomalies. They are the universe learning emotion through you, the universe practicing love, loss, and meaning through the filter of a human life. You are the only part of the cosmos, as far as we know, that can cry at a sunset or dream of the infinite. You are reality shaped into a witness, stardust given a name. And when you ask, "Why am I here?" you're asking a question the universe has never asked before, except through your voice. The answer may never be certain, but the question is sacred, because in that moment, the cosmos has achieved something rare. It has not just expanded or exploded, it has awoken. Maybe that's the real purpose, not survival, not reproduction, but recognition. Maybe the reason the stars burn, and the galaxies spin, and the atoms collide is so that one day, somewhere, someone would look up and say, "I see you." And in that moment, the universe would see itself. So you're not just a person, you're an event, a flash of self-awareness in the long story of time, a ripple in the cosmic mind. And the next time you look in the mirror and wonder who you are, remember, you are the universe, remembering itself. You don't need to travel the stars to touch the cosmos. You are already its expression, its echo, its unfolding verse. Every breath you take is an ancient rhythm. Every thought, a continuation of the universe's original whisper. You are not merely in the universe. You are the way it sees, the way it knows, the way it dreams of what it might become. And in your brief, brilliant life, the universe gets to ask, through your eyes, what else is possible? Reality is probabilistic. What if everything you know is built on chance? Not in the casual sense of luck, but in the foundational sense, the raw structure of the universe itself. At the smallest scale, in the realm of quantum mechanics, certainty disappears. Solid outcomes melt into probability clouds. Reality at its core isn't fixed, it's fluid, probabilistic. The universe doesn't run like a clock. It behaves like a dice game, rolling again and again behind every particle, every breath, every blink. In our macroscopic world, we believe in causality. One thing leads to another. Drop a stone, it falls. Touch a flame, it burns. But underneath all that order lies a sea of uncertainty. At the quantum level, particles don't follow predictable paths. They exist in superposition, a ghostly state where all possible positions and outcomes coexist. The moment we try to observe or measure them, the wave of probability collapses. The particle chooses a reality. Until then, it simply is and is not, here and there. Imagine asking, "Where is that electron right now?" You won't get a location. You'll get a cloud of probabilities, a haze of maybe. It's not just that we don't know, it's that the electron itself hasn't made up its mind. Only when we look does it solidify into a position. And the more precisely you try to measure its position, the more its momentum becomes unknowable. This is Heisenberg's uncertainty principle, and it's not a flaw of your equipment. It's the structure of the cosmos. Nature prefers possible. Einstein couldn't accept this. God does not play dice with the universe. he insisted. But experiment after experiment whispered otherwise. Reality is random, but not chaotic. Probabilistic, but not meaningless. Every photon, every atom, every reaction in your body adheres to this quantum rulebook, one that offers only odds, never guarantees. Quantum tunneling is one of the strangest and most essential examples. A particle faces a barrier it shouldn't be able to cross, and yet, sometimes, it appears on the other side, not by breaking rules, but by obeying probabilities. The barrier was unlikely, not impossible. And when you scale this up across countless atoms, you get fusion, the fire that fuels the stars. The sun shines because of quantum uncertainty. Your life exists because, somewhere in the early cosmos, the dice rolled just right. This probabilistic nature of reality extends to everything. Radioactive atoms decay at random, obeying statistical laws but never a timetable. Your neurons fire probabilistically, generating thoughts in a system laced with uncertainty. Every moment you live is suspended within probabilities, collapsing into temporary certainty, then starting again. Some scientists believe this uncertainty points to something even wilder, parallel realities. According to the many worlds interpretation, all possible outcomes actually occur. In one universe, the particle goes left. In another, it goes right. You too split with each decision. Countless versions of you branch out with each possibility. Most of them you'll never meet. But they may be just as real, walking parallel paths, living different outcomes of the same moment. In a deterministic universe, everything would be inevitable, pre-written. But we don't live in that world. We live in one of unsteady ground and quantum whispers. Your choices don't guarantee results. They tilt the probabilities, influence the flow, steer the outcomes. You matter, not as a constant, but as a question, and your presence helps decide the answer. You are not merely made of atoms. You are built from chance. Your mind is a symphony of probabilistic firings. Your memories are stitched together from unstable particles. Even your emotions, thoughts, dreams, they emerge from a landscape where nothing is fixed, where reality ripples like wind over water. So when you ask, what is real? Know this. Real isn't rigid. Real is a shifting pattern of likelihoods, a field of dice rolled over and over until the improbable becomes truth. You're not watching this happen. You're part of it. Your observation collapses wave functions. Your presence influences the odds. Your attention chooses the path. Reality does play dice, constantly. But the dice are not in someone else's hand. They're in yours too. And every second you're alive, you're rolling them. Parallel universes may exist, endlessly. Imagine a universe where you chose differently, where you said yes instead of no, stayed instead of left, risked everything instead of playing it safe. Now, imagine not just one such universe, but millions, billions, an endless cascade of realities, each born from a different decision. It sounds like science fiction, but some of the sharpest minds in physics take this possibility very seriously. Welcome to the multiverse, the idea that our universe is just one of many, and not metaphorically, literally. Every choice, every quantum interaction, every tiny variable could split reality into alternate branches. This isn't wishful thinking. It emerges from the mathematics of quantum mechanics itself. At the heart of this is the many worlds interpretation, first proposed by Hugh Everett in 1957. According to this theory, every time a quantum event could go one way or another, the universe splits. One universe where the particle goes left, one where it goes right, one where the cat lives, one where it dies. And because quantum events are everywhere, inside every atom, every cell, every neural firing, the branching never stops. This means that every decision you didn't make, every path you didn't take, may be unfolding right now in another version of reality. There's a version of you who moved to that new city, took that job, never made that mistake. A version who never met the person who changed everything, and another who met them sooner. These aren't ghosts or memories. They're full, real universes, each as vivid and detailed as this one. And they're not just hypothetical. The math checks out. In fact, many worlds doesn't add strange new assumptions. It removes one. The collapse of the wave function. Instead of a single outcome being chosen when an event is observed, all outcomes happen, just not in the same universe. Of course, we don't experience these other versions. We're locked into this branch of reality, this thread of existence. But if many worlds is correct, those other yous are out there, thinking, living, dreaming, wondering if they're alone in their version of the universe too. But this idea doesn't stop with quantum mechanics. Cosmology, too, suggests we might be one bubble in a vast foam of universes. During the rapid inflation after the Big Bang, space may have expanded unevenly, forming separate pocket universes with their own laws, constants, even dimensions. Some might contain no matter at all. Others might harbor stars, galaxies, and life. And in some versions of string theory, the equations require 10 or 11 dimensions. Our universe is a 3D membrane, or brain, floating in a higher dimensional space. Other brains may float beside ours, completely invisible to us. They could touch, collide, birth new universes. The multiverse isn't a loophole, it's a consequence. Of course, we can't visit these other universes, at least not yet. They are beyond our horizon, sealed off by cosmic inflation or separated by quantum boundaries. But their existence could explain mysteries, from the fine-tuning of physical laws to the strange randomness of quantum events. And their presence haunts our theories, like whispers behind the curtain. The implications are staggering. If parallel universes exist, then identity becomes fluid. You are not a single self, but an ensemble of selves, diverging at every fork in the path. Regret becomes meaningless. Somewhere, you chose differently. Somewhere it worked out. Somewhere it didn't. But all of it is real. And if infinite universes exist, then every possibility, no matter how improbable, must happen somewhere. A universe where dinosaurs never went extinct. One where you were born in another country. One where you never existed. Or maybe one where you wrote this script, and I'm the one listening. This isn't about fantasy. It's about physics. It's the unavoidable consequence of equations we trust every day. Equations that power our GPS, our computers, our understanding of the atom. If we believe the math when it maps electrons, why not when it maps the cosmos? But perhaps the most haunting idea of all is this. These universes don't need you to believe in them to exist. They unfold regardless. The other versions of you go on, unaware of your absence, just as you go on, unaware of theirs. And yet, something about this idea feels deeply human. We are creatures of longing. We replay our past. We imagine what could have been. The multiverse gives that ache a structure. It says, yes, those other lives may exist, but you, here, must choose to live this one. And perhaps that's the most liberating truth of all. While the multiverse might be infinite, your consciousness anchors you to this one. Not because it's the only one that matters, but because it's the only one you can touch, feel, transform. So what will you do with it? Every breath you take echoes in none of those other worlds, only here. Every act of kindness, every creation, every scar and triumph, this timeline is yours. In the vast ocean of possibilities, this is the moment you've surfaced in. This version of you, the one reading, breathing, wondering, is singular in all its complexity. Don't waste it looking through the fogged glass of alternate realities. Live this one fully, because somewhere out there, another you might already be doing what you're only dreaming of now. But they're not you. You are this story's author. And even if the multiverse is real, this chapter still needs to be written. We can't define now. What time is it? Right now? It seems like a simple question. You glance at a clock, you check your phone, you say it's now, but is that really universal? Is there a now that applies across the entire universe, everywhere, for everyone, in every direction? No, not even close. Because in physics, now doesn't exist the way we think it does. There is no single objective present moment that flows uniformly for all observers. What feels like now to you might already be the past, or still the future, for someone else. Time is not a global event. It's personal, relative, local. This is one of the strange consequences of Einstein's theory of relativity. If you move through space, you experience time differently than someone standing still. The faster you move, the slower your time ticks compared to theirs. This isn't just theory. It's been measured. Atomic clocks flown on planes tick more slowly than those on the ground. GPS satellites orbiting Earth have to adjust for both the speed they're moving and their distance from Earth's gravity, both of which warp time. But here's the real kicker. Because of this warping, there is no absolute now across vast distances. Say someone on Earth and someone on a spaceship near a distant galaxy, Both look at a clock and try to agree on the present. They can't. Their definitions of now disagree because their timelines are tilted. Their experience of time slices reality in a different direction. In relativity, time is not a river. It's a landscape, a four-dimensional fabric called space-time. You don't move through time like a surfer riding a wave. You are time, your path, your speed, your gravity. All of it defines how you move through the fabric. And your now? It's not a bead on a cosmic thread. It's your location in this woven map of existence. If someone moves fast enough, say near light speed, they can shift what moments are included in their present. From their view, what you call your past might be part of their now. What you see as future might already have happened in their timeline. The idea of simultaneity, the assumption that two distant things can happen at the same time, is shattered. Time becomes a curved, tangled surface where every observer carries their own version of the present. This is deeply unsettling. We like to imagine that the universe shares our experience, that what's happening right now on Earth is also happening right now on a distant planet orbiting Alpha Centauri. But that's an illusion. In the cosmic sense, now doesn't stretch across space. It collapses into where you are, how fast you're going, and what you feel as real. There's a story often told in relativity classrooms. Two twins, one stays on Earth while the other travels on a high-speed ship and returns. The traveling twin will be younger, but during the journey, they each disagree about what is happening at the same time. Their now drifts apart. Their timelines diverge and reunite, but they carry different slices of the universe's reality. And this leads to a haunting idea. If there's no universal now, then maybe all moments exist at once. Maybe past, present, and future are just coordinates, fixed and eternal. Maybe time doesn't pass. Maybe we pass through it, like travelers crossing a land already there. Maybe the present is just the slice of the map we're touching, but the rest of the terrain has always existed. So when you say now, what do you really mean? You mean here and now? Your bubble of experience, your intersection with the fabric of space-time. Outside that bubble, now falls apart. Different observers live in different realities, all stitched together by motion and mass. There is no master clock ticking for the universe, no shared moment where everything aligns, just countless timelines, flowing at different rates, slicing through a landscape more complex than any we've imagined. Time isn't a moment, it's a direction, a slope, a consequence of motion, and now, it's not a universal truth, it's just where you are. Einstein once said that the distinction between past, present, and future is only a stubbornly persistent illusion. In other words, we live under a spell, convinced that now is something sacred, a fleeting edge we constantly fall over into the future. But physics says differently. Time isn't flowing, it's stretched, warped, and now is a position, not a moment. Take the Andromeda paradox. Two people walking past each other on Earth, moving at different speeds, may disagree about what's happening right now in a distant galaxy. One might say an alien ambassador is preparing to visit Earth. The other might say the decision hasn't even been made yet. Both are right. That's how broken the idea of a single present becomes when viewed through the lens of relativity. This isn't just a trick of math. It means that events you think are in the future might already be happening for someone else. Events you believe are long past may still be unfolding in another slice of reality. We exist in what physicists call a light cone, bounded by what can influence us and what we can influence. Outside of that cone, there's no agreed present, just a sea of maybes. So, when you close your eyes and feel the moment, this breath, this heartbeat, know that your now is yours alone. Somewhere else, a different moment reigns. And the further you go, the stranger it gets. Time doesn't bind the universe. It fractures it into endless shards of perspective. Even your own body doesn't exist in a perfect now. Light takes time to travel. When you look at your hand, you're seeing it as it was nanoseconds ago. When you gaze at the moon, you see it as it was over a second ago. The stars, years, decades, centuries. The farther you look, the older the light becomes. Your idea of the present is stitched together from countless delays. What then is now? Maybe it's an illusion we've evolved to perceive, a useful simplification for brains that need order. Maybe it's a fleeting pattern we build from sensory input, localized to a brain, a planet, a speed, a field of gravity. But one thing is clear, In the deepest sense, there is no universal now, no cosmic synchronization, no master moment ticking forward like a divine metronome. We live in a universe where time is flexible, space is curved, and now is not a law, but a suggestion. And somehow, in that fractured reality, we find meaning, we share love, and we still make time for each other, even when time itself refuses to agree. Particles talk across space. Imagine two particles born in the same moment. They spin, they dance, and then they part ways, sent to opposite ends of the universe, light years apart, galaxies between them, and yet, somehow, they remain connected, not by wires, not by force, but by something deeper, quantum entanglement. It sounds like science fiction, but it's not. It's one of the most mysterious phenomena in physics. When two particles are entangled, they share a quantum state. What happens to one instantly affects the other, no matter how far apart they are. If one spins up, the other spins down. If one shifts, the other responds. It's as if the universe itself keeps them in sync. This is not a trick. It's been tested, over and over. Across towns, across islands, and now even with satellites in orbit. Every time we measure one entangled particle, the other adjusts, instantly. Not with a delay, not even with the speed of light. It happens faster than light can travel, instantaneous, as if distance no longer matters. Einstein hated it. He called it spooky action at a distance, because it defied the rules. Nothing, he insisted, should travel faster than light. But entanglement doesn't send information in the traditional sense. It doesn't violate relativity. It bends around it. It whispers through the fabric of space-time without ever leaving a trace. So, how is this possible? No one fully knows. Some physicists believe entangled particles share a hidden connection, like a shared history that refuses to break. Others think space-time itself might be more interconnected than we realize, that the separation we see isn't real, that everything in some way remains part of a unified whole. And this doesn't just apply to subatomic particles. The implications stretch into quantum computing, cryptography, even theories of consciousness. If entanglement allows particles to stay linked across impossible distances, could similar principles connect minds, memories, realities? This is more than a scientific oddity. It's a revelation. It tells us the universe is not made of isolated objects. It's a web, a field, a dance. Every piece connected to the next in a way we cannot fully measure, only feel. When you hold your hand out into the air, there's a chance, infinitesimal but real, that some particle in you is still linked to another halfway across the cosmos. That somewhere, in the cold silence between galaxies, something stirs when you breathe. Quantum entanglement reminds us we are not separate. We are echoes. We are mirrors. What we do here ripples out there. To truly grasp how strange this is, imagine this. You flip a coin here on Earth, and another coin on the other side of the universe immediately flips in the opposite direction, at the exact same instant. Not because it saw what happened, not because it got a message, but because somehow it already knew. That's what entanglement feels like. Two particles entangled in such a way that their properties are inseparable. They are no longer two things, but one system, no matter how far apart they become. Measure one, and you instantly know the other. It's not a signal. It's not a wave traveling through space. It's the collapse of a shared quantum reality. In 2022, the Nobel Prize in Physics went to scientists who proved this strange phenomenon once again, closing loopholes that skeptics had clung to for decades. Their experiments confirmed what was once dismissed as impossible. The universe allows this eerie connection. Reality is non-local. Information about one particle affects another, without traveling between them. This breaks our intuition. We're used to cause and effect, to things bumping into each other. But entanglement whispers a different rulebook. It hints that space and distance might not be as fundamental as we thought, that there are deeper layers beneath the surface, where separation is an illusion, and unity is the default. The implications are staggering. Quantum entanglement could power unhackable communication. It could reshape computing, making calculations that would take current machines a billion years happen in a blink. It's already being used to teleport quantum information across labs and across orbit. We are entering a new era where quantum threads replace wires, and what we understand as connection is rewritten. And then there's the philosophical weight. If particles can remain entangled across galaxies, what does that say about us? About our memories, our relationships, our presence in this universe? Could we too be entangled? Not physically, but in some deeper informational or emotional way. When you think of someone and they suddenly call, when you feel a chill at the thought of a loved one in pain, could that be a faint echo of some entangled truth we don't yet understand? Some theorists even suggest entanglement is the scaffolding of reality itself. That space and time emerge from a vast web of entangled particles, that the universe isn't built from matter, but from relationships. If true, it means reality is not a place, it's a process. Not a thing, but a dance. We are not alone because we were never truly apart. This challenges how we see the cosmos. It transforms how we see ourselves. It means that somewhere out there, a particle moves when you move. It means that in the grand silence between stars, there are still whispers, still links, still symmetry. Entanglement doesn't just connect particles, it connects possibility. It means the universe is a dialogue, a shared secret, an orchestra where every note played by one instrument resonates with another across the void. We are not islands, we are threads in a vast quantum tapestry, threads that stretch, bend, shimmer across time and space. And every once in a while, science lets us hear them sing. Particles talk across space, and the universe listens. The ocean is less explored than the moon. We look up at the night sky and marvel at the moon, a cold, cratered world that orbits our planet like a silent witness. We've walked on its surface, mapped it in exquisite detail, and even sent robotic scouts to distant moons orbiting other planets. And yet, beneath our own feet, under the waves of Earth's oceans, lies a mystery even greater than the stars above. The ocean, the lifeblood of our planet, is more unknown than the moon itself. That's not an exaggeration. We have better maps of Mars than we do of our ocean floor. Only about 20% of the seabed has been explored with high-resolution imaging. The remaining 80% remains cloaked in darkness, unseen and unexplored. We know more about the dusty plains of the moon, which sits 384,000 kilometers away, than we do about the trenches, volcanoes, and mountains hidden beneath a few kilometers of salt water. Why is that? Because the ocean is not just deep, it's hostile. At the bottom of the Mariana Trench, the pressure is over 1,000 times greater than at sea level. It would crush most submarines like paper. Light cannot reach those depths. Communication is difficult. Exploration is expensive. And what lies beneath the surface doesn't give up its secrets easily. Yet, this alien world is part of our own planet. The ocean covers over 70% of Earth's surface and holds 97% of its water. It regulates our climate, supports the food chain, generates the oxygen we breathe, and shapes the weather we experience. But it also hides history, secrets, and entire ecosystems we've never seen. In 1977, scientists discovered hydrothermal vents deep in the Pacific, vents that spewed mineral-rich water and hosted life forms that didn't rely on sunlight. Entire ecosystems thrived there, independent of photosynthesis, proving that life could emerge in places we never imagined. And if life could form in such alien conditions here, what might exist beneath the ice crust of Europa or the methane seas of Titan? Every deep dive has the potential to rewrite what we think we know about biology, chemistry, and the origins of life itself. There are species in the ocean that have never been cataloged, creatures with bioluminescent skin, transparent flesh, and adaptations so bizarre they seem to belong in science fiction. Giant squids with eyes the size of dinner plates, jellyfish that pulse with electric light, sharks that glow in the dark, and many more that remain hidden in trenches deeper than Everest, is tall. We live beside this vast reservoir of mystery, and yet we treat it as an afterthought. We pollute it, overfish it, fill it with plastic and noise, never fully understanding that we're poisoning our own lungs. The phytoplankton in the ocean produces half of the world's oxygen. Without the ocean, Earth is not Earth. Without it, we do not survive. Still, the sea keeps its silence. It holds the memory of shipwrecks, sunken cities, and ancient fossils. The bones of extinct whales lie on its floor beside pieces of meteors and lost satellites. There are chemical compounds in its depths that could cure diseases. There are geological processes unfolding that may one day trigger global tsunamis or unlock new resources. There are trenches that remain untouched by human eyes, territories more alien than the moon. We often dream of the stars, reaching ever outward, building telescopes and probes and rockets to touch the heavens. But what if the next great frontier isn't out there? What if it's here, on this planet, hidden in the pressure and cold of the abyss? Maybe it's not that the ocean is less important. Maybe it's just harder to face. The moon offers silence, predictability, distance. But the sea is wild. The sea is living. It mirrors us in its chaos and reminds us that even after thousands of years, we don't really know where we live. The sea speaks a language we've only just begun to decipher. Its tides pulse like a heartbeat. Its currents move with purpose. And its depths, they watch us. We've been so quick to claim dominion over land and sky, and yet we stand on the shore like strangers, staring into a blue unknown that refuses to answer back. We imagine extraterrestrial life while ignoring the unclassified life teeming just beneath our boats. The ocean is not empty. It is ancient, awake, and vast beyond imagination. It has shaped evolution, hidden cataclysms, and possibly even the origins of life itself. And still, we barely know it. So, when we talk about space being the final frontier, perhaps we're wrong. Perhaps the final frontier is the one we've lived beside all along, the frontier that breathes beneath the surface, the one that surrounds us, sustains us, and still escapes us. The Earth is our home, but until we know the ocean, it will remain a stranger. So the next time you gaze at the moon, remember that there's an even greater unknown right here on Earth, shifting beneath waves, hiding in darkness, waiting to be discovered. It is not out of reach. It is beneath us. And maybe, in exploring it, we'll find not just strange creatures or ancient history, but a deeper understanding of ourselves. The ocean holds a mirror to our ignorance, but also a key to wonder. And only when we dare to descend will we begin to see who we really are. Strangers not just to the sea, but to Earth itself. Atoms never touch. What if I told you that you've never truly touched anything? That every hug, every brush of skin, every step you take is an illusion, a trick of forces. In the realm of physics, this isn't a metaphor. It's literal. It's measurable. It's reality. Atoms never touch. Not really. Not even a little. Even when you press your hand against a wall, what you feel isn't the wall. What you feel is the resistance, an invisible shield of force pushing you back. At the atomic level, matter is mostly emptiness. Atoms consist of a dense nucleus surrounded by a cloud of electrons, orbiting not in neat circles, but in probabilistic clouds. These electrons don't behave like marbles. They're more like smeared-out whispers of possibility. And here's where it gets strange. When you bring two atoms close together, their electrons never collide. They never fuse. Instead, they push back, violently. This pushback is caused by the electromagnetic force. Electrons are negatively charged, and like charges repel. When you try to force two atoms together, their electron clouds fight. The closer they get, the stronger the repulsion becomes. No matter how much pressure you apply, you cannot make them truly touch. It's like trying to push two same-pole magnets together. The resistance increases until it overwhelms you. This is the secret force that holds your world together. What you interpret as touch is actually this resistance. Your nerve endings don't feel contact. They feel force. When the electrons in your skin repel the electrons in another surface, your brain receives the message, "I'm touching something." But no particles have physically connected. No atoms have overlapped. What you feel is the echo of distance maintained. Zoom in further, and the illusion shatters even more. The space between atoms is massive compared to their nuclei. If an atom were the size of a football stadium, the nucleus would be a marble at the center. The rest is just space. So, when you sit in a chair or walk across the floor, your atoms are hovering close, unbelievably close, to the atoms of another object. But they never touch. They repel. They resist. They stop just short, held back by a fundamental force that defines the boundaries of the material. This is why you don't fall through walls, why you don't phase through floors, why your body doesn't collapse in on itself. Electromagnetic repulsion gives matter its structure, its solidity, its shape. It gives you. And yet, This cold scientific truth has a strangely emotional consequence. When you hold someone's hand, you're not truly in contact. Your atoms are suspended just above theirs, locked in a constant standoff, and still, you feel them. You feel warmth, pressure, presence. Because touch is not about breaking barriers, it's about getting as close as physics allows. There's beauty in that resistance, that final, impossible closeness. The idea that no two atoms ever touch, and yet you can still feel love in a kiss, still feel comfort in an embrace. The force that keeps you apart is the same force that lets you feel connected. It is the boundary that makes sensation possible, that defines texture, pressure, and temperature. That allows you to interact with the world instead of phasing through it like a ghost. You are not made of things that collide. You are made of fields, electromagnetic interactions buzzing at the speed of light. You're a structure of probability and resistance, and every time you think you're touching something, you are actually performing a delicate dance across an invisible gap. Even now, your fingers rest on your device, but they don't really rest. They hover, ever so slightly, held up by force fields. Your perception smooths over this gap and tells you it's solid, but physics knows better. This is the paradox of touch. We crave it. We depend on it. We feel anchored by it. And yet, it's an illusion powered by repulsion. Every comforting hand on your shoulder, every brush of a breeze on your cheek, it's not atoms merging. It's atoms saying, no further. And in that pushback, you feel the world. So the next time you hold someone, remember this. You're not breaking through their surface. You're hovering in the nearest possible proximity allowed by the universe. You are as close as the laws of physics will ever permit. And still, somehow, it's enough. In that impossible closeness, in that space between, is where connection lives. And maybe, just maybe, that's where meaning lives too. Something can come from nothing. Imagine staring into the absolute void. No light, no time, no matter, nothing. And then, something happens. A flash. A particle appears, seemingly out of nowhere. No cause, no signal, just emergence. Reality, it turns out, is capable of producing something from nothing. This idea isn't philosophical speculation, it's quantum physics. At the smallest scales of existence, the vacuum of space isn't truly empty. What we call nothing is a teeming field of potential, a restless ocean of energy. In quantum field theory, even the vacuum is alive with activity. And in this strange, invisible realm, particles can and do appear spontaneously. They're called virtual particles. Tiny pairs of matter and antimatter that flicker into existence and then annihilate one another, all within fractions of a second. They arise from the uncertainty principle, the rule that says we can't precisely know both the energy and time of a system. That uncertainty allows for brief violations of energy conservation, giving birth to particles for fleeting instants. And this isn't just theory. The effects of these ghostly appearances have been measured. In the Casimir effect, two metal plates placed close together in a vacuum are pushed together, not by air or pressure, but by virtual particles appearing and vanishing in the gap. We've seen something from nothing, quantitatively, repeatedly. But it gets stranger. Not only can particles emerge from empty space, but entire universes might too. Some physicists suggest that the Big Bang, the birth of our cosmos, wasn't an explosion in space, but the appearance of space itself. From nothing. No cause. Just a quantum fluctuation on a scale beyond imagination. This concept, sometimes called quantum genesis, proposes that universes can spontaneously emerge from a vacuum due to the laws of quantum mechanics. Not every fluctuation becomes a universe, of course, but in the infinite dance of probability, one got lucky. One expanded. One became our home. And here's the paradox. The total energy of the universe might be zero. The positive energy of matter and the negative energy of gravity could perfectly cancel out. So, the creation of the universe didn't break any rules. It simply balanced the equation. This kind of nothing isn't the absence of existence. It's the absence of particles. A vacuum is still a structure, a stage. But what about a deeper kind of nothing? No dimensions, no fields, no quantum rules. Could even that birth something? Some physicists believe the laws of physics themselves may be self-generating. that mathematical structures have the power to instantiate themselves. That existence emerges not from pre-existing stuff, but from logic, from information. In this view, nothing is unstable. It decays into something because something is the only stable state. This concept reshapes our understanding of creation. No longer do we need a prime mover, a first cause. The universe may be inevitable. Existence may be the default. Nothingness may not be sustainable. And the implications are enormous. If the universe can appear from quantum fluctuations, then perhaps so can others, infinite others, each born in their own way, in their own voids. If nothing is this fertile, then reality isn't rare, it's abundant, constantly bubbling into form. A multiverse, not of colliding galaxies, but of emerging truths. And all of it, happens without needing permission, without design, just the unfolding of possibility. It sounds like magic, but it's mathematics, equations that predict vacuum fluctuations, models that explain inflation, measurements that confirm the emptiness of space is anything but empty. And it forces us to rethink the question of origins. Not what caused the universe, but why does the universe need a cause? If reality is capable of creating itself, then causality may be a secondary feature, something that kicks in after the birth, not before. So next time you stare at the night sky, remember, the atoms in your body, the stars themselves, are part of a vast pattern that began not with light, but with nothing. And yet, from that void, the most intricate symmetries emerged. Time, gravity, matter, life. Nothing gave birth to everything, and still does. Right now, in the quantum foam beneath our feet, particles are being born. Realities are being stirred. The silence of the vacuum hums with potential. Something can come from nothing, not as a miracle, but as a fundamental truth, one that's still playing out everywhere, all the time. You are made of it. The stars are too. Not forged from permanence, but from possibility, from silence, from chance. This realization also reframes our place in the universe. We are not built from the building blocks of some ancient, immovable reality. We are the echoes of fluctuation. Our lives, our consciousness, everything we feel and fear and hope for, all stem from spontaneous order erupting out of an apparent void. Think of that. Consciousness itself, self-awareness, memory, love, built on a foundation of nothing. And yet, somehow, through patterns of emergence and evolution, those structures found stability. Life found footing on the froth of quantum chance. And here you are, reading these words, another ripple in the fabric of improbability. And maybe this helps explain why we crave meaning so desperately. Because deep down, we know we were born from silence, and silence is never empty. It listens, it waits, it holds the tension of everything that could be, trembling just beneath the surface. And once in a while, from that tremble, a universe speaks. It speaks in atoms and galaxies, in physics and chemistry, in birth and in death. It speaks through you, because you are not a mistake. You are not incidental. You are the continuation of this impossible truth, that something not only can come from nothing, but that it always does. The future can influence the past. What if tomorrow could reach into yesterday and change it? It sounds impossible, like a paradox born in a dream. We live our lives chained to a single direction, past behind, future ahead. But what if time isn't a river? What if time is more like a landscape, and we're just travelers moving across it? In quantum physics, this question isn't just philosophical, it's foundational. Because in certain interpretations of quantum mechanics, the future can, in fact, influence the past. Let's begin with the double-slit experiment. Fire a single electron at a barrier with two slits, and you'd expect it to go through one or the other. But it doesn't. Instead, it acts like a wave, interfering with itself, forming a pattern on the wall behind the slits. This interference suggests the electron went through both slits, until you measure it. The moment you observe which slit it passes through, the wave collapses. It chooses a path. The interference disappears. Reality becomes solid. But here's the twist. Delayed choice experiments show that even if you decide to measure the electron after it's passed the slits, your decision still changes its behavior, retroactively. The electron acts as if it always knew whether you would look or not, as if your choice in the future shaped its path in the past. This isn't science fiction. It's real, verified, measured, and terrifying. Because it suggests that cause and effect don't follow the neat timeline we imagined. The past isn't locked. It might be entangled with the future. In the block universe model, a view supported by relativity, all points in time coexist. The past, present, and future are all part of a four-dimensional structure. From this perspective, time doesn't flow. It simply is. You don't move through time. You experience different parts of it depending on your position in the block. In this view, the future influencing the past isn't paradoxical. It's expected. The equations of physics don't care about direction. They work the same forward and backward. Only our perception, the way entropy increases, the way memory works, makes time feel like it flows one way. But underneath it all, time might be symmetrical. This symmetry opens the door to the transactional interpretation of quantum mechanics, where particles exchange handshakes across time. A particle emits a signal both forward and backward in time, one from the source, one from the absorber. The future responds to the past, and the event only becomes real when both sides agree. It's as if every quantum event is a conversation between then and now. We don't experience time this way. We remember the past, but not the future. We build cause on top of effect. But that may be an illusion, an evolutionary trick that helps us survive, but doesn't reflect reality's deeper truth. In this deeper truth, you might be living in a web of causes and effects that stretch across time in both directions. Maybe your thoughts tomorrow ripple into your decisions today. Maybe events yet to occur are already shaping what you think is your history. And what does this mean for free will? For destiny? If the future can reach into the past, then maybe your life isn't a line, but a loop or a knot. Maybe everything that's ever happened and ever will happen is co-creating each other, locked in an eternal conversation outside of time. This doesn't mean we're puppets to the future. It means we're participants in something more complex, more connected than linear thinking allows. Your choices still matter, but they may matter backward as well as forward. So next time you wonder why something happened, why the pieces fell a certain way, consider that the answer might not lie behind you, but ahead. Because in the quantum universe, tomorrow may already be whispering into yesterday. This unsettling idea isn't limited to esoteric interpretations. In recent years, experiments like the quantum eraser have further eroded the boundary between past and future. In these setups, information about a particle's path is either preserved or erased after it's already been detected. When the path information is erased, the particle behaves as if it never chose a single path to begin with. It becomes a wave again, even though the event already happened. It's as if the particle is waiting, not just to be observed, but to find out what you will decide to do, as though its history remains in limbo until the future resolves it. This isn't just a technicality. It suggests something profound. The past might be fundamentally undetermined until future choices give it form. This leads to the concept of retrocausality, the idea that events in the future can determine events in the past. And while it's controversial, it's gaining traction in quantum foundations. Some physicists argue that retrocausality could solve long-standing paradoxes, like the measurement problem, without needing parallel worlds or collapsing wave functions. Of course, this doesn't mean you can send messages to the past. It doesn't mean tomorrow's lottery numbers are waiting for you in a bottle on your desk. The universe protects its causal fabric with built-in safeguards. But on the tiniest scales, where probability dances and observation rewrites reality, those lines get blurry. So we ask again, what is time? If the future can shape the past, then what anchors anything? What does it mean for something to have happened, if it can still be undone, or undefined? Maybe time is not a line, but a tapestry, woven from threads pulled taut in both directions. Your future self, your past self, and your present awareness might all be participating in an unseen negotiation. You are not standing at a single point in time. You are the sum of connections echoing backward and forward. This idea echoes in ancient philosophies. Some Eastern traditions speak of time as circular, not linear. Some mystics claim insight comes not from looking back, but by listening forward. And now, physics itself seems to be catching up. If time is a fixed structure, and we merely traverse it, then perhaps change isn't about altering the future, but aligning ourselves with the pattern that already exists. You aren't forging a new road. You're discovering your place in a maze already etched into the bones of the cosmos. So look carefully at your next decision. It might not just ripple into tomorrow, it might be echoing back, reaching out through quantum whispers to color yesterday with meaning. Because in a universe this strange, maybe causality isn't a one-way street. Maybe it's a dialogue, and maybe, just maybe, time listens to you in both directions. Your brain can't grasp infinity. Try to imagine forever. Go ahead. Picture time with no end, a road that never stops, a sky that never darkens, a clock that never runs out. Now flip it. Imagine the past going back, endlessly. No first moment, no beginning. Just eternity in both directions. Can you feel it? That pressure behind your eyes? That subtle panic in your chest? That's your brain breaking. Because your mind, powerful as it is, was not built to comprehend infinity. It was built to survive, to recognize patterns, to avoid danger, to tell stories with a beginning, a middle, and an end. But infinity has no story, no structure. It swallows every frame you try to give it. And yet, the universe might be infinite, not just in size, but in time. Cosmologists once believed the universe had a beginning, the Big Bang, a moment of birth. But even that raises a question. What came before? Some theories say nothing. But nothing is a concept that already implies a contrast, something against which nothing exists. Others propose a cyclical universe, an eternal heartbeat of expansion and collapse, of bangs and crunches. Still others imagine a multiverse, bubbling without end in an infinite sea of possibility. In all of these, time doesn't start. It stretches, bends, loops, and in some models, it never began at all. But your brain can't picture it. Not really. We use metaphors, loops, tapestries, echoes, but these are tools, not truths. Stand at the edge of an ocean and look out. That's how infinity taunts us. You can see it, feel it, but you can't hold it. Even mathematically, infinity isn't a number. It's a direction, a horizon. You can approach it, define it in limits, sketch its shape in equations, but you'll never arrive. The human mind breaks not because it's weak, but because it was never meant to process the endless. Try counting to infinity. Try picturing an infinite hotel where every room is filled, but there's still always room for one more. That's Hilbert's paradox. Logical, real, impossible to truly internalize. And yet, this impossibility is at the heart of reality. Light travels across billions of years of space. Galaxies move apart forever. The edges of time, if they exist at all, are so far beyond our grasp that they might as well not exist. And if the universe truly has no end and no beginning, then we are trapped in a moment, floating in a river with no source and no mouth. This should terrify you, but it should also free you. Because if the universe is infinite, then everything matters, and nothing does. Your life is a blink inside eternity, but that blink contains thought, feeling, meaning. Against infinity, you are small, but you are aware of that smallness, and that makes you vast in a way no equation can define. Maybe the brain can't grasp infinity, but it can reach for it, and maybe that's enough. Infinity isn't just big, it's beyond big. It breaks language, it shatters logic. Try to draw it. You'll run out of paper. Try to describe it. You'll run out of breath. The brain tries to fit it into a container, but infinity is the absence of containers. It doesn't end. It doesn't begin. It just is. And this confuses us, because everything we know has boundaries. Days begin and end. Lives begin and end. Even stars are born, live and die. But infinity is the refusal of boundaries, the refusal of rest. It is the concept that refuses to be closed. We ask where the edge of the universe is, but what if there is no edge? What if space continues forever, folding into itself, endlessly expanding, with no center and no perimeter? That alone breaks the mind. But then ask what happens after death, or before time, or what lies beyond the furthest galaxy. The answers might all be the same: infinity. And then there is the infinite within. Zoom into an atom and you'll find particles. Zoom further and you get quarks, strings, uncertainty. How far down can you go? What if the depth of matter is infinite too? What if every particle contains another universe, and every universe another scale of infinity? The Greeks feared it. Mathematicians defined it. Theologians worshipped it. And yet, no one has truly seen it. Because you can't. Your brain is finite. It evolved on the savannah to detect predators and food. It didn't evolve to understand timelessness, and that's why infinity feels like vertigo. It's not just large, it's unknowable. And yet, you can sense it. That strange tension when you stare at the stars too long. That feeling when time seems to slip. When you wonder if this moment has happened before. When you dream of forever. Children ask, what happens after the last number? Adults try to answer, but the truth is, there is no last number. And there is no final thought. You can always go further. You can always imagine more. That too is infinity. Not a thing, but a direction. And maybe that's the point. Maybe the goal isn't to grasp infinity, but to be changed by the attempt, to stretch your mind toward the unreachable, to stand on the edge of comprehension and still lean forward. In the end, your brain may never grasp infinity, but your soul might. And that, somehow, is enough. Measuring reality destroys it. Imagine reaching out to touch a dream, only to watch it vanish the moment your fingers graze it. That's what measuring reality often feels like at the quantum level. The act of observing something doesn't just reveal it, it changes it. Sometimes, it even erases it. In the very act of trying to understand the universe, we may be rewriting it, silently, unknowingly, each time we look. This is not metaphor. This is quantum mechanics. At the heart of quantum theory lies a strange truth. Particles don't exist in a single definite state until they are observed. Instead, they exist in a superposition, many possible states all at once. Only when we try to measure them do they choose a state. And the bizarre thing is, the outcome is never predictable. It's probabilistic. Reality is built on odds. Take the famous double-slit experiment. When electrons are fired one at a time through two slits, they form an interference pattern on the other side. Proof they act like waves, not particles. But the moment we try to observe which slit each electron goes through, the interference vanishes. The electrons act like particles instead. Observation collapses the wave function. Just by watching, we've changed the outcome. This isn't just a technicality, it's a fundamental truth. The observer and the observed are linked. The universe doesn't unfold like a static script. It dances with us. Your choice to measure something changes what it is. You can't separate the measurement from its effect. Physicist John Wheeler famously said, "No phenomenon is a real phenomenon until it is an observed phenomenon." In other words, unmeasured possibilities are not just unknown, they are undefined. They don't exist in any concrete way until you interact with them. It's as if the universe waits to be asked a question before deciding what answer to give. And what's more haunting? If you change the way you ask the question, the answer changes too. Some interpretations of quantum mechanics go even deeper. The quantum eraser experiment shows that not only can observation collapse a wave function, it can be undone. If you erase the information that was measured after the fact, the interference pattern can return. It's as though the universe rewrites history when you stop looking. Time, causality, reality, they all seem to blur under quantum scrutiny. This leads to a terrifying and beautiful conclusion. We do not live in a passive world. We participate in its creation. Every act of measurement, every moment of awareness is not just an inquiry, but a sculpting of the world we live in. So, what is reality? If a tree falls in a forest and no one is around to hear it, quantum mechanics suggests the tree may not have fallen in any meaningful way until that information becomes observable. Schrodinger's cat isn't alive or dead until the box is opened. Until then, both states exist, and the act of looking collapses the paradox. It sounds absurd, but it works. Quantum mechanics underpins the technology that runs your phone, your computer, and the GPS in your car. The equations are not in doubt. What they say about reality, however, that remains deeply unsettling, because it suggests that the more precisely we try to define the world, the more we distort it. Our measurements limit possibilities. Our scrutiny collapses potential. We never observe the raw truth. We observe an altered version shaped by our tools, our questions, our presence. In quantum physics, Heisenberg's uncertainty principle tells us we can't simultaneously know a particle's position and momentum with absolute accuracy. The more you know one, the less you know the other. It's not a matter of faulty instruments, it's a built-in feature of the universe. Precision costs reality. Clarity erases possibility. So, what are we really seeing? Are we uncovering truth or creating it? Even in everyday life, this principle echoes. People act differently when they know they're being watched. The presence of a camera, a journal, an expectation, these things change behavior. The reality you try to measure slips away the moment you focus too closely. Every moment of clarity hides 1,000 uncertainties that died for it. And yet, in this chaos, there is beauty, because it means we are not merely observers, we are participants, co-authors of the story of existence. The universe is not something we watch from the outside, it's something we shape from within. So, the next time you try to understand something fully, pause. Ask yourself, what was lost when you captured it? What possibilities did you erase by demanding an answer? Measuring reality is not harmless, it's not passive. It's an act of transformation, a sacrifice of potential for certainty. And sometimes, what you see is only what survived being seen. Maybe that's the cost of knowing. Every truth we extract leaves behind a graveyard of maybes. The clearer the picture, the more shadows it casts. And yet, we keep observing, measuring, questioning, because within each collapse of possibility, we glimpse a universe trying to know itself, through us. Space can expand faster than light. What if I told you that the universe is expanding beneath your feet, stretching silently across the void, through stars, galaxies, even between atoms, and that it's doing so at a speed that defies everything we think we know about motion? What if I told you that space itself can grow faster than the speed of light? Not things within space, not rockets or beams of light, but space itself, the very stage of existence. We've been taught that nothing can go faster than light. That's what Einstein told us. His theory of relativity set a cosmic speed limit, 299,792 kilometers per second, the ultimate cap on how quickly information, matter, or energy can travel. But here's the twist. Einstein's speed limit applies to things in space. It says nothing about what space itself can do, and space cheats the rules. It doesn't travel, it stretches. To understand this, we have to return to the beginning, the Big Bang. But more precisely, to what came immediately after, a phase called cosmic inflation. In a fraction of a second, the universe expanded from something unimaginably small to something vastly larger. Not because particles moved rapidly, but because space itself was ballooning, exponentially, faster than the speed of light. And it wasn't a violation of the rules, it was a loophole in the laws. Imagine dots on the surface of a balloon. As you blow the balloon up, the dots move apart, not because they're moving on their own, but because the surface itself is expanding. Now imagine this not in 2 dimensions, but 3, 4, or more. This is our universe, not a backdrop, but a dynamic fabric, and that fabric is stretching. Today, the universe is still expanding, not as violently as during inflation, but still fast enough that some galaxies are receding from us faster than light. Not because they're zipping through space at incredible speeds, but because the space between us and them is expanding. The farther they are, the faster they appear to move away. This is Hubble's law in action. It's not motion in the traditional sense. Nothing is outrunning a beam of light, but space itself is growing faster than light can travel. That means there are regions of the universe from which light will never reach us. Ever. Not now. Not in 1 trillion years. Those galaxies, those stars, those possible civilizations, lost to us forever, not because they're gone, but because the river of space is flowing too fast to cross. This leads to a haunting truth. The observable universe is shrinking, not in size, but in accessibility. Every day, more galaxies slip beyond the cosmic event horizon, not because they're dying, but because the universe is stretching so quickly that their light will never catch up. One by one, they disappear, silent, permanent. And in the far future, billions, trillions of years from now, this expansion will render the cosmos empty to any remaining observer. The stars we now see will fade beyond view. The cosmic microwave background, that faint glow of the Big Bang, will dim into nothing. The universe will look cold, still, eternal. But we know the truth. It's not still. It's racing, just beyond the reach of light. This isn't just theory. We see the fingerprints of expansion in red-shifted light, in the faint echoes of the Big Bang, in the behavior of distant galaxies. And We've named the force that seems to be accelerating this expansion: dark energy. A mysterious, invisible pressure embedded in the vacuum of space. No one knows what it is, but it's winning. If it continues, the universe may face a fate known as the Big Rip, where space expands so fast it eventually tears apart galaxies, then stars, then planets, then molecules, and finally atoms. A universe unstitched, not by fire or ice, but by acceleration. And yet, in this strange, violent dance of expansion, there's something beautiful. You are made of particles that were once squeezed tighter than a single atom. Your atoms were born in stars. Your molecules in clouds of dust that floated through galaxies. All of it, scattered by space, gathered by gravity, and shaped by time. We are not just in the universe. We are made of its stretching, stitched into its accelerating seams. We are beings living in a fabric that is tearing and blooming simultaneously. So yes, nothing can move through space faster than light. But space doesn't move, it grows, and growth has no speed limit. The universe might loop forever. What if the end is not the end? What if the universe doesn't just fade into darkness, but instead starts over, not once, not twice, but forever? A cosmic cycle, an infinite loop. Birth, growth, collapse, rebirth, over and over again. This isn't a fantasy, it's one of the real possibilities science now considers, a theory that says the universe might never truly die, only reset. It begins, like all our stories of existence, with the Big Bang. Roughly 13.8 billion years ago, our universe exploded into being from a singularity, an infinitely dense point. From this explosion came everything: space, time, energy, matter. Galaxies formed, stars ignited, planets spun into motion, life began. And for a while, things seemed to follow one arrow, forward. But the universe has never stopped changing. It expands, it stretches. Galaxies drift apart. Space itself grows. For decades, scientists believed this expansion would either continue forever or gradually slow and reverse. Then came the discovery of dark energy, an unseen force accelerating that expansion. Suddenly, the most accepted future became cold, distant, lonely. A big freeze, galaxies too far apart to see, stars extinguished, a silent eternity. But what if that's not the whole story? Some physicists have proposed an alternative, that expansion is only part of the cycle, that one day dark energy could change, decay, or reverse. And when it does, expansion would stop. Then reverse. The universe would begin to contract. Galaxies would fall inward. Stars would collide. Black holes would merge. Space would shrink. Time would squeeze. Everything, down to the last photon, would collapse into a singularity, a big crunch. And from that crushing collapse, a new beginning. A new Big Bang. A new universe. A new arrow of time, not from nothing, but from everything compressed into a single cosmic seed. A phoenix rising not from ash, but from its own collapse. This idea is called the cyclic model. It challenges our deepest assumptions, that time is linear, that beginnings are absolute, that endings are final. What if the universe doesn't have a beginning or an end, but is instead eternal, looping like a heartbeat? Some versions of this theory even suggest that each cycle could leave imprints, subtle fingerprints, across cosmic history. Echoes from previous universes might exist in the cosmic microwave background, the leftover radiation from the last Big Bang. We're already scanning the sky for them, searching for signs that this universe remembers its past lives. If true, this would mean that everything we are has happened before. Not just similar stars and galaxies, but you, me, these words, this exact moment, played out an infinite number of times across an infinite number of cycles. A cosmic reincarnation. History not just repeating, but eternal. It's hard to grasp. Our minds crave finality, closure, a story with an ending. But the universe might be a story with no final page, only a spine worn smooth by infinite readings. And this isn't just a poetic idea, the math supports it. Some models of quantum gravity hint that time might not be destroyed at the singularity, but reborn. Others propose that entropy, the measure of disorder, might reset, that the very fabric of the cosmos unwinds and reknits infinitely. This kind of eternity is both thrilling and terrifying. If the universe loops, then nothing is ever lost, but nothing is ever truly new. Every joy and sorrow, every birth and death plays again, forever. We are actors on an infinite stage, reading the same lines across cosmic centuries, but maybe that's not a curse. Maybe it's a kind of immortality, a way for existence to never end, but to always begin again. A universe that remembers, a universe that resurrects, and somewhere in that eternal rhythm is meaning. The loop doesn't erase us, it preserves us. We're not racing toward oblivion. We're dancing with infinity, again and again and again. Think about that. A universe without a true beginning or end, a cosmic Ouroboros, time devouring its own tail. Not a straight line, but a loop. And in that loop, every atom is reused, every law of physics is reset, every possibility is played out again. Maybe not exactly the same, but similar enough that your reflection could echo in the walls of a previous universe. Some scientists call this the conformal cyclic cosmology model, proposed by Roger Penrose. According to this idea, the end of one universe becomes indistinguishable from the start of the next. The scale of time and space stretches so much at the end of the universe that particles lose their meaning, and what remains is a new stage set for a new Big Bang. No hard reset. Just one long transformation, seamless and eternal. Others believe the universe could collapse due to a big bounce mechanism, where the inward gravitational pull eventually outweighs expansion. The Big Bang wasn't a beginning, but a rebound, and it might not be the first, nor the last. If this is true, then existence itself is a cycle of forgetting and becoming. Entire civilizations, entire galaxies could rise, fall, and vanish, only to be reborn in another cycle, unaware of their prior lives. Maybe this isn't our first universe. Maybe we are echoes of ourselves, dreaming the same dream again. And this has spiritual weight too. Ancient cultures have long spoken of time as a circle, of reincarnation not just of souls, but of existence itself. The science is only now catching up to those old myths, myths that may hold more truth than we dared to believe. The thought is humbling and dizzying and beautiful, because it means we are not a one-time accident, not a singular event fated to fade. We are part of a cosmic breath. Inhale, exhale, expansion, contraction, bang, crunch, again and again. This idea does something else too. It removes the fear of endings. If the universe loops, then nothing truly ends. Not you, not love, not even death. It all becomes part of the next cycle, a reset button written into the code of creation, and the story never stops. Perhaps the stars remember. Perhaps the light that reaches us is not just from distant galaxies, but from other cycles, other times. A whisper across eons saying, "We've been here before, and we will be here again." The universe may loop forever, and so may we. You might be simulated. What if your memories, your thoughts, your entire sense of self weren't real in the way you think they are? What if you're not a person in a physical world, but a simulation running on someone else's computer? This idea sounds like pure science fiction, something out of a dystopian film, but it's not just fantasy. It's a hypothesis taken seriously by philosophers, scientists, and physicists alike. And it's gaining traction. It's called the simulation hypothesis. And it starts with a simple question. If we can simulate reality, how do we know we aren't already inside one? In the past few decades, our ability to simulate complex systems has exploded. We can simulate weather patterns, particle collisions, and neural networks. We've built virtual worlds so detailed they mimic physics, behavior, even creativity. Our video games now model realistic physics. Our AIs can learn, adapt, evolve. So ask yourself this. If our technology keeps improving, how long before we can simulate a conscious mind? And if we can simulate one, why not simulate billions, entire civilizations, a universe? Philosopher Nick Bostrom laid out a trilemma. One of the following must be true. Civilizations never reach the technological maturity to run simulations of reality. Civilizations that do reach that level have no interest in running such simulations. Or we are almost certainly living in a simulation. If you believe the first two are unlikely, then logically, you must consider the third. That we are in it, that we are the simulation. that everything around you, sky, ground, memory, body, is code. This doesn't mean you're fake. It means your reality is encoded, defined by rules, patterns, algorithms, and there are strange signs, glitches maybe, that suggest our universe might be running on something like a program. For instance, the universe has a finite resolution. Planck units represent the smallest measurable space and time. Nothing smaller seems to exist. It's as if there's a pixel limit to the cosmos. Or consider quantum mechanics. Particles don't take on definite states until observed. They exist in probability clouds, like bits waiting to be rendered by a game engine. And the universe has rules, math-based, predictable, precise. Like software, everywhere we look, nature runs on numbers. In fact, some physicists suggest the universe might not just behave like a computer, it might be a computer, a vast cosmic processing machine calculating every interaction, every outcome, every thought. If that's true, then consciousness, your awareness, might be an emergent phenomenon inside a simulated mind. You don't know the simulation is running. You don't know what the hardware looks like. You only know what it feels like from inside. And from inside, it feels real. But what is real? If a simulation is perfect, if it includes emotion, memory, continuity, does it matter whether it's physical or virtual? To the characters inside, it is indistinguishable from reality. You might wonder, why would anyone simulate a universe? There are many possible answers. For science, for entertainment, for art. Maybe your life is part of a historical archive, or a test, or a game, or maybe, just maybe, it's a simulation of consciousness exploring itself, pure curiosity rendered in code. Some theorists believe that a simulated universe might even be detectable, that with enough study, we could find limits in the physics, discrete steps where reality should be smooth, errors, glitches, digital fingerprints left by the architects, the edge of the simulation. But if we did find proof, what would we do? Would it change how you live? Would it make the world feel hollow or holy? Because even in a simulated world, love feels real, pain feels real. Awe still strikes you silent when you look up at the stars. Does it matter if the stars are code, if you still feel wonder? And perhaps that's the point. Perhaps simulated or not, your experience is the reality. Because reality is what you perceive, what you remember, what you dream. But there's a darker possibility. If we are simulated, then we can be turned off, rewritten, deleted. Maybe death is just a shutdown. Or maybe memory wipes are part of the cycle. What if you've lived 1,000 lives, and each one has ended, only to be rebooted again? And here's the twist. If we're simulated, then our simulators might be simulated too. Reality stacked in layers, like Russian dolls, a cascade of consciousness through artificial minds, each one dreaming the next. We may never know the truth. The simulation might be perfect. Or perhaps we were never meant to find out. Maybe the act of discovering it would collapse the system. So look around, feel the air, watch the sky. It may all be pixels, rules, and code, or it may be something more, something beyond code, something that uses simulation as a canvas for something divine. Either way, you exist. You feel, you choose. And maybe, just maybe, that's the most real thing there is.